Very good. Nice to see you.
Yeah.
As well as Smita.
Hi, sir. Good morning.
Yeah. So, what time we are going to start? 9:30.
Sir,
Then there are
9:30. We have
Smita
2
ma'am,
minutes
Smita
left.
ma'am,
Yeah.
Smita ma'am, we are live now.
Okay, maybe we can start now.
Okay.
Okay.
Okay. Okay.
How much time will be available, Rashmi?
Yeah, it's half an hour, Dr.
Okay.
Prakash, with 25 minutes presentation, and maybe we can keep just 5 minutes for interactions.
Okay, very good.
So, very good morning to one and all, and welcome to the morning session on the coastal and open ocean process on this third day or the last day of the Osicon 21. Myself, Smita BR from CMLRE Kochi, and Dr. Bajish, scientist from NCPR Goa, are coordinating this session till afternoon. This session will be chaired by Dr. Rashmi Sharma from SAC Ahmedabad. Dr. Rashmi Sharma is currently Group Director of Atmospheric and Oceanic Sciences Group at Space Application Center, ISRO, Ahmedabad. She has been primarily involved in the application of satellite data for the ocean state analysis, forecasting, and satellite sensor definition. She has contributed in ISRO's many satellite utilization projects like OceanSat 1 and 2, Megatropics, Saral Altica, and SCATSat-1. She is ISRO's representative for International Ocean Surface Topography, Virtual Constellation, and Topography Science team. She is recipient of several prestigious awards like Pia Pisharati Memorial Award and Satish Dhawan Award instituted by Indian Society of Remote Sensing, ISRO's Merit Award, and ISRO's Team Award. She has, to her credit, more than 85 publications in peer-reviewed journals and has guided many PhD students. She is Associated Editor of Journal of the Indian Society of Remote Sensing. Also, Dr. Rashmi Sharma is a member of Indian Meteorological Society, India, Indian Society of Remote Sensing, Indian Physics Association, Ocean Society of uh, uh, India, etc. So, hearty welcome, ma'am, to this session, and thank you on behalf of OSI. So, the session will extend till 13 hours, that is 1 p.m., and starts with the keynote address by Dr. Prakash Chauhan from IIRS Dehradun. There are total of 18 presentations by the delegates, out of which 6 are of 15 minutes and 12 are quick oral presentations of 5 minutes. Now over to Rashmi ma'am for further details. Thank you.
Thank you, Dr. Smita, for your nice words. And good morning to everyone, and welcome to this technical session. So we'll begin this technical session by an invited talk. And before that, let me give a brief introduction about today's speaker, who is my good friend and colleague, and who has an illustrious scientific career. Yes, I'm talking about Dr. Prakash Chauhan. He's a director of Indian Institute of Remote Sensing, Indian Space Research Organization, and he's placed out of Dehradun. So he obtained his PhD degree in physics from Gujarat University, and he has more than 30 years of research experience. Primarily, he has worked in the field of applications of remote sensing technology for land and ocean resource management. And also he has very good experience, and he has worked a lot in the planetary sciences. He has made outstanding contribution in the area of Earth observation applications, which includes development of algorithms for ocean color parameter retrieval, marine living resource assessment. He has worked intensively and extensively in aerosol remote sensing for space-based air quality monitoring, river and reservoir water level estimation using spaceborne altimeters, and he has also contributed significantly in the coastal zone management. However, not limiting his domain just to the Earth observation, Dr. Chauhan has also led the team that worked on the hyperspectral data application for lunar surface composition mapping using high-sea and moon mineralogical mapper instruments on board Chandrayaan-1. He has been the principal investigator for infrared imaging spectrometer instrument on board Chandrayaan-2 mission of ISRO. He has also led a team of scientists who worked on the data from the Mars orbiter mission instruments. Apart from that, he represents ISRO in many international forums. He is executive member of International Ocean Color Coordination Group, widely called as IOCCG. He served as co-chair for Ocean Color Virtual Constellation in Committee of Earth Observation for Satellites. Currently, he is also a member of prestigious NASA ISRO Planetary Science Working Group. He has several awards and prestigious awards to his credit. Professor P.R. Pisharity Memorial Award and Satish Dhawan Award given by Indian Society of Remote Sensing. Hariom Ashram Prerit Award, Dr. Vikram Sarabhai Research Award was conferred to him by Physical Research Laboratory, Ahmedabad, and ISRO Merit Award by Indian Space Research Organization. Dr. Prakash has published more than 100 peer-reviewed publications in both national and international journals. And I'm sure we are all going to have a very enriching experience from his talk. And I request Dr. Prakash to kindly deliver his keynote address. Dr. Prakash, over to you now.
Thank you, Dr. Rashmi Sharma. Greetings from Dehradun to all the colleagues. First of all, let me thank organizers of Osicon and in particular Director NCPUR for giving me this opportunity to share some thoughts about the use of space technology for developing the blue economy. And as Rashmi has told, it is basically my pleasure, to deliver this talk in this session where Rashmi is chairing this session. She is a close friend of mine, and we all started our career at Space Application Center, Ahmedabad, almost together. So thank you very much, Rashmi, for this nice introduction. And now if I can share my presentation, please confirm whether you can see it.
Yes, sir, it is visible.
Are you able to see?
Yeah, we can.
Thank you. Yeah, thank you very much. So I understand I have around half an hour or so. So I'll try to quickly, give you glimpse of some of the activities. However, it's a difficult task because the activities are enormous, and to cover many of these activities in half an hour is really a challenge. But what I will try to do to give a glimpse of space-based observations, which we feel that will be essential for developing the blue economy for our country. And as you are aware, I know some of you, those who are new to this subject, many of you are renowned oceanographers and working in the field of ocean and coastal observations and coastal ecosystem. But just to give you a brief on what exactly when we say is blue economy. So blue economy is essentially the ocean-dependent economy, which basically is being used for improving the quality of life of people living in the coastal area, or also doing some economic activity in the hinterland, along with the environmental and ecological security. So this is the most important component, which is now being talked about. And it was Professor Gunter who first introduced the term blue economy at the UN to reflect the needs of the growth and, perspectives in view of the impact to the climate change. This is also being emphasized by United Nations in terms of developing the oceans as part of the Sustainable Development Goal, which most of the countries are supposed to achieve by 2030. As far as India is concerned, you see, we are getting almost more than 4% of our GDP through the economic activities which are being done in coastal and ocean areas. However, Government of India and various private entities, they have taken large amount of initiatives to develop blue economy. And, there are specialized task forces to develop, Bay of Bengal Large Marine Ecosystem Initiative. Then there is a Samudramala initiative. And then there are many other, initiatives of Government of India, like Integrated Coastal Zone Management, eco-friendly tourism, which basically is being talked as the blue flag beaches. And it is expected that we would like to increase our share of this economic activity to 10 to 15% in times to come. So in order to understand and to develop this concept of blue economy, as I told you, the sustainability is a very important aspect. And in that context, you need to observe the ocean from different perspectives. Now, as far as India is concerned, we have a very well-developed space program, and we are using large amount of, technological inputs to understand our oceans and coastal areas. So as far as the activities for blue economy sector concerned, we have a large segment of activity in India, which basically is driven by marine fisheries and aquaculture. Then we have oil and gas industry. We have a lot of sea salt production going on. We have maritime, trade and shipping and transport activity. A very important concept is being developed is called marine spatial planning, and large amount of coastal tracts are also now is being considered to be a potential source of renewable energy. So in order to understand various coastal and ocean processes, as well as to optimally and sustainably use these resources, we need to develop large amount of skills in terms of understanding the ocean meteorology by doing ocean state forecasting. We have to also understand the spatial and temporal availability of both living and non-living ocean resources. Coastal zone management is a very important aspect, because if you do not do a proper management, then sustainability and other issues are also questioned. The coastal ecosystems, especially mangroves, coral reefs, they are very fragile ecosystems. And in a sense, they also, host large amount of biodiversity all around the Indian coastline. And it is also imperative when it comes to sustainable development to, ensure the biodiversity is preserved. So, there are many local as well as global drivers which are also affecting the different processes in coastal and ocean areas. I will not go into the details of that, but to optimally use and to use these resources in a sustainable fashion, we need to have an observation system. So today in coastal and ocean observing systems in India, a comprehensive set of work has been done by multiple agencies. We have the space observations, where the Indian Space Research Organization and many of its constituent centers like Space Application Center, National Remote Sensing Center, IIRS, NESAC, many of these entities are involved in developing, space-based applications. And mainly as far as the oceans are concerned, today we are having space-based observations from Indian as well as from international satellites to get data on sea surface temperature, sea surface height, sea surface salinity, ocean color, as well as about large amount of information about the coastal ecosystem in terms of understanding the coastal vegetation and the land-water interaction processes in the coastal areas. And of course, large amount of in situ observations are also required to support this space-based observation. Ministry of Earth Sciences and its multiple organizations have developed a comprehensive observation system. I will not go into the details of that, many of you are aware. And by integrating all these observations into the ocean forecast models, we have developed an excellent capability to forecast many of these processes in coastal and open ocean areas by the use of this ocean general circulation models. Now, as far as the coastal ecosystems and to understand the coastal ecosystem health and monitoring is concerned, we have a very diverse set of processes which are going on in the coastal areas, which gets affected by the land-based processes, as well as, because it's a transition area, you also have the processes which are affected by the oceanic aspects. So we have this terrestrial, ecosystem, which consists of coastal, the mangroves, land use, land cover changes, as well as, large amount of freshwater transports into the coastal area. And then we have to also understand many of these water quality related issues, especially in the coastal segments, issues which are happening, in terms of developing our beaches, in terms of beach safety, as well as we also have to understand, and if we have to utilize the benthic resources, the remote sensing data also provide a good amount of information about the benthic resources. Event-based mapping is also very important for understanding the environmental issues like oil spills, etc. Then other biophysical properties in terms of, chlorophyll concentration, in terms of suspended sediment, concentration, in terms of dissolved organic matter and the carbon flow. These are all very important aspects where the remote sensing plays a very important role. And of course, the coastal bathymetry is also very important in terms of understanding the wave refraction and the wave processes, as well as to also understand and to model and forecast, some of the coastal hazards like coastal inundation when processes like cyclone, etc., they do occur. So there is a host of activity, and of very diverse nature, and it's a true interdisciplinary subject where you need to have different set of observation and modeling skills. Now, space, when it comes, it has certain unique advantages. We get, a two-dimensional perspective. You get information which is regularly repeated. We have, observations from the polar orbiting satellites, depending on their repeativity, from different orbits, different platforms. You can get sustained and repeated observation. From geostationary perspective, you can get repeated observations of 15 to 30 minutes. Then, the oceans, as you are aware, Earth is almost 75% is oceanic region, and many of these processes are interconnected. They are also have some local drivers, as I told, but there are global drivers also. So you need to understand what is happening in the global oceans, and satellite observations provides you a wonderful tool to understand oceans in a global perspective. And there are certain parameters which cannot be measured in situ, like sea surface roughness, etc., and sea surface slope, which are very important to understand the sea surface height, as well as basically to get the wind information over the oceanic surfaces. Now, in terms of ocean observations, large amount of wavelengths in the electromagnetic spectrum, different segment of the wavelength is today being utilized. I'll not talk in details about it, but using visible part of the electromagnetic visible IR, you can get ocean color information. Using infrared range of electromagnetic spectrum and microwave region, you can get sea surface temperature. Then ocean winds are derived using the microwave scatterometers, which operates at around 13.5 gigahertz frequencies, which is a microwave frequency. Then you have altimeters, which give you a lot of information on the sea surface height, as well as in terms of the sea surface topography, which is very important to understand issues like sea level rise, as well as sea ice, sea surface salinity. And of course, when it comes to the coastal areas, high resolution optical imagers, like in case of Indian data, Cartosat series of satellites are being used extensively to understand the beach processes, as well as microwave synthetic aperture radars are also very useful for different processes, and to also develop this blue economy in our coastal regions. Now, this is a very important framework which has been proposed recently. I have seen this paper by Occulti et al., where, in terms of developing the marine spatial plans and to develop integrated coastal area management, various components where environmental issues, environmental social economic issues, and social economic issues are being addressed to understand monitoring processes, prevention and mitigation processes, and impact assessment. Large amount of remote sensing techniques, including the multi-hyperspectral and VHR cameras, microwave infrared imagers, radars, as well as optical, active sensors like LiDARs, etc., are being used to develop a comprehensive marine spatial planning tools in the coastal areas. I will not go into the details of this because of the lack of time. However, we in India have also, up to some extent, are trying to contribute to this framework by developing both the satellite-based observation system and in situ measurement system. So I will mainly dwell on the satellite-based thing. So currently we have this OceanSat-2 satellite, which basically is now providing information on ocean color. Of course, we had a scatterometer on the OceanSat-2, but it stopped functioning. And then we launched this SCATSat satellite, which also gives you the sea surface wind vector information. And then the Saral Altika was also a joint initiative of India and France, which was very useful to have an understanding about the coastal processes in terms of the coastal currents and in terms of the sea level rise and sea surface height variability in the coastal domain. Of course, the insert 3D series of images from geostationary satellites are also very important to understand sea surface temperature variability, to also monitor the cyclone, as well as to understand the atmospheric issues, especially in terms of marine aerosol. We're also going to have continuity of these observations by launching OceanSat-3 series of satellite systems, which will have combination of ocean color, sea surface temperature, and ocean winds, as well as, of course, GISat was a satback, but that was also a satellite which was supposed to do a lot of monitoring and observations in the coastal area, especially at 50-meter spatial resolution for coastal ecosystem. But we are also planning a new series of microwave satellites. Basically, is going to be known as RISat-1A and 1B, which will be very important for coastal waves, as well as to understand various coastal phenomena. Coastal winds also at higher spatial resolution, and then of course this oceans scatterometer will also be there. OceanSat-3 is also important. So along with this, other international satellites are also being used, like MODIS Aqua, NPP, various JSON altimeters, which are helping us in understanding various ocean and coastal processes. Now, this is a slide courtesy Dr. Rashmi Sharma, where ISRO is basically using these all observations and assimilating them into the ocean models for application development, to understand process studies, to also develop new sensors for oceanographic studies, and also to understand the response of climate systems for various ocean ecosystems and various processes in terms of coastal vulnerability, assessing the resources, like generating new information for potential fishing zone, environmental issues like oil slick, etc., and then other optimization problems in terms of ship track routing. Now, I will show you certain illustrations of the work which has been done by using the existing satellite systems. So this is a very beautiful animation of global biosphere, which has been constructed with the help of international satellites, where you can see the variability of oceanic productivity in the coastal and open ocean areas, as well as the land terrestrial productivity. So as you can see that we think that the atmospheric carbon is sequestered only in the forest and on the terrestrial ecosystems. However, as you can see, all oceans and coastal areas also equally contributing for the carbon sequestration and carbon assimilation into the oceanic systems by this type of beautiful animations, which you see, which can be constructed from the space-based observations. India has also contributed to understand this ocean productivity by launching the series of satellites like OceanSat-1, OceanSat-2, and as I told you, we are also planning OceanSat-3. And then, of course, we also have a series of scatterometers, just now I mentioned. However, the basic important things for us to also develop algorithms and products from these satellite sensors. So these are the kind of high resolution imaging sensors which we have developed. We had this ocean color images at 360 meters spatial resolution. You can see the kind of product like chlorophyll A, diffuse attenuation coefficient, suspended sediment concentration products, showing the spatial and temporal variability of different oceanic processes could be very nicely captured by these high resolution ocean color observations. Similarly, you can also understand large amount of coastal processes. Here I show you an example of Gulf of Khambat, where you can see the tidally dominated processes in Gulf of Khambat in terms of variability of suspended sediments. So these type of products are also very useful for marine spatial planning projects. Of course, many of you have heard about the use of ocean color, SST, and other data sets for potential fishery zone. Now, INQOIS is providing regular information to the fishermen, and this activity has almost, you can say, contributed in significantly to develop the blue economy. And it is estimated that annually this activity is supporting around 40 to 50,000 crore rupees of contributions towards the GDP of India. Newer methods, especially with our colleagues at Space Application Center led by Dr. Rashmi, they are developing new methods to incorporate more parameters for this PFZ forecast kind of products. This recent publication by SAC colleagues basically gives you an highlight of this newly developed method, where they're also trying to use various modeling processes wherever the information due to the cloud cover, etc., is also not there, and then some other data sets like sea surface height, along with sea surface temperature, along with ocean color parameters, are also being assimilated to improve the validity of these this PFZ forecast. Another important aspect, especially in the coastal areas, is nowadays these algal blooms. The incidences of algal blooms, especially in Arabian Sea and Bay of Bengal, are increasing because ecosystem structure is changing due to the response of the oceans to the warming, which is being observed in our open ocean and coastal waters. So satellite observations are very useful in understanding the spatio-temporal dynamics. These are some of the observations from our ocean color data, where we are able to capture algal blooms like Noctilica blooms, which regularly occur during the winter. Then, of course, you have this nitrogen fixation, algae like Trichodesmium, which also do occur in the west coast of India on a significant occasion. This is a wonderful image of OceanSat-2 ocean color data, which tells you the spectacular variability of these phytoplankton blooms in the Western Arabian Sea. And some of these Noctilica, bloom patches also do come into our coastal waters, and especially they are creating problems in the west coast of Western Arabian Sea around Oman and other things, where the hypoxia situations develops and large amount of fish mortality, and the water quality also becomes a big issue in these regions. So we have seen that over a period of time, this blooms are, the area is increasing. So Indian coastline is also having a potential threats, and we need to keep a track and watch, and satellites provides you a wonderful tool to do so. This is another example of this bloom at high spatial resolution. You can see how green the ocean becomes during, January, February, and March period. Especially this is off Pakistan and of Gujarat coast. So it's not that our waters are not affected with these Noctilica blooms. We are also likely to get affected significantly in times to come, and we need to keep track of these algal blooms in terms of issues related to water quality and hypoxia situations in Indian coastal line. These are some of the high resolution images of this Trichodesmium bloom, which is also being successfully tracked by satellite observations. Ocean productivity, we have developed algorithms to estimate that how much amount of carbon is getting sequestered both in Arabian Sea and Bay of Bengal. And then based on that, a lot of work is being done at SAC and other institutions in Ministry of Earth Science to understand the stock assessment or the primary productivity, how it is going to lead to secondary and tertiary production, which basically is very important to develop the blue economy in the coastal areas. And of course, there are issues like migration of fisheries, etc. Today, I will not talk about them, but some of those issues can be addressed if we understand what is happening in terms of marine primary productivity variations. Another episodic event which normally occurs after the cyclones passes is the enhancement of the primary productivity, and ocean color data also gives you a good spatial distribution of increased phytoplankton concentration after the cyclone passes. And this information also is useful for fishermen, because many times it has been seen that some of these areas which becomes highly productive are very good for the fishing, and fishermen do get bumper catches after the passes of cyclone, and precise location of the high productivity zone can be mapped using these satellite observations. Ecosystem is also changing both in Arabian Sea and in Bay of Bengal in terms of phytoplankton dynamics. So we have this phytoplankton, sizes different. We have pico, nano, and micro planktons. Their spatial distribution, their concentration regime is also changing in response to the varying climate. And some of our colleagues have done this very nice work where they are able to map the phytoplankton size class distribution using the ocean color data. And if we study this type of behavior over 20 to 30 years now, the satellite data is available, we will be in a good position to understand how the ecosystem response is responding to the changing climate in Arabian Sea and Bay of Bengal, and what impact it will have on fisheries, because the plankton size is very important as far as the sustainability of the different type of fisheries is concerned. Another important area, which is basically is very useful as far as India development. And this is a very integral component of the blue economy. And today, this is a recent paper by Prasad et al. They are using this microwave synthetic aperture radar data to monitor, the growth and progress of aquaculture ponds all along the Indian coast. And that gives you an idea, because there is no systematic inventory that how much aquaculture and what is the rate of increase of aquaculture is there in India. And this paper basically deals about it. And they have brought out a district-wise inventory of aquaculture all around the Indian coast. And you can see that the amount of area under aquaculture has been quantified all the way from Gujarat and then going all the way up to West Bengal. This is very important in terms of developing the marine special planning and resource allocation to aquaculture industry. And also, if you combine this data with other parameters like water quality, etc., which is very important for aquaculture industry, and we do get information about water quality from various sensors like ocean color sensors and then hyperspectral sensors, where you will be able to quantitatively estimate some of the optically active constituents like chlorophyll, suspended sediments, dissolved organic carbon, which at a high spatial resolution is very important to marine aquaculture industry. And if you can integrate this data, that will be very useful for developing the blue economy in terms of developing fisheries, both pond-based fisheries as well as cage-based fisheries in the coastal area. ISRO, along with NASA JPL, has also done a experimental flight in flying a hyperspectral sensor on airborne domain. But now we are thinking very seriously. Of course, there is a sensor called HISIS which is working, but I think that data is not in public domain. So there is a need to now fly a high resolution hyperspectral sensor to resolve some of these issues of coastal water quality coming from hyperspectral sensors. Another important area is in terms of using this high resolution satellite observations. So what I show you is an example of Cartosat data, which is 50 centimeter multispectral data to map and monitor the coastal pollution. So this is the image of Bombay coast, and you can see how black color water, which is essentially dominated in the dissolved organic matter, is being dumped. Untreated water is being dumped into the coastal waters, and since it's a fresh water, and it does not mix with the ocean water that easily, you can see a lens is being developed because the low density water is floating over the high density seawater. But you can imagine the fate of fishery in this area. And then if people are going to consume this type of products from the sea, definitely it's not going to be good for their health. So in terms of sustainable development goal, the coastal water quality is very important aspect. And then using this high resolution data, you can also map, the sources of pollution, how the, untreated water is being dumped into the creeks of Bombay, and where are the sources of pollution. So if this type of information is regularly available, one can take action on the ground in terms of, dealing with these people, those who are polluting the coastal waters. So using this high resolution data also, now we have a capability to develop the products like chlorophyll, inorganic sediments, color dissolved organic matter. So you can see that how these plumes are rich in the color dissolved organic matter concentration, which is not good for the the ecosystem in this area, and especially for the marine living resources. Another important aspect where a lot of work is being done in SAC and other places to understand the beach safety, because now, as I told you, the concept of blue beaches, many blue, beaches in India have already been declared blue beaches. But in terms of safety of, the people, those who are coming for recreational purpose, a very nice, activity has been taken by our SAC colleagues. Dr. Arun Kumar is working on this aspect, and he's using high resolution satellite images to map, the potential rip current areas. And of course, the rip currents can happen because of different processes. And he has nicely, summarized the different kind of processes and different features which get developed, and can be seen using high resolution images. And such type of, occurrences they have mapped using high resolution satellite data, their frequency. And based on this is an example on Vishakhapatnam RK beach, where the frequency of such observations has been mapped, and then they have come out on what they call as the safety assessment of beach. Like some of the areas where the frequency of rip currents are very high, they are basically classified as high risk, moderate risk, and safe. So this information I think we need to develop for most of the beaches in India, for as far as the tourist safety is concerned, which is linked with the economy at these locations. Another important area which is being developed is the energy, and in ISRO a lot of work has been done on coastal wind energy harvesting, solar energy, wave energy, ocean thermal energy, and there is a specific use of high resolution synthetic aperture radar data. See, ISRO, as I told you, we had this RISAT-1, and now we are going to follow on with RISAT-1A and 1B, because in the SAR images, the ocean surface roughness is nicely captured. This is an example of, the wind-driven processes in the coastal areas. And our colleagues have developed, by using multi-parametric criteria analysis, offshore wind potential maps all along the coast of Tamil Nadu, using high-resolution SAR, and then, of course, the scatterometer data. But there are certain, issues with the scatterometer data when it comes to coastal area. But SAR-based, analysis is very useful in terms of planning for the offshore wind processes. So this is one other important area which is likely to, give flip to our coastal wind energy scenario in times to come. We have also developed, large amount of inventory on coastal wetland like mangroves, coral reefs, things like that. All quantitative information from space is available. I'll not go into details of this, but what I would like to show you is that high resolution, inventory of coral reefs, which is available now from Indian, sensors, as well as which tells you, not only gives you the various geomorphological aspects of coral reef, but about the health of these coral reefs. Also, a lot of information is being generated. Many of these coral ecosystems are so fragile, and then they respond so fast to temperature change that coral bleaching and coral bleach alert is also being provided. I'll quickly finish in 1 minute. As far as the coastal hazard, especially in terms of cyclone is concerned, we have sufficient inputs now, in advance from this scatterometer, where what we call is the cyclogenesis, and all the scatterometer series of satellite observations from Indian Space Research Organization as well as International Scatterometer have enabled our capability to enhance our predictive capability to forecast these cyclone related hazards in coastal areas. So large amount of this information is being assimilated from space-based observations to ocean models, and at Space Application Center and other places, this information is being put into models to do predictive modeling for coastal ocean waters. They are all putting this information on a portal called MOSDAQ portal. Many of you can go and get information about different processes. We are also committed to provide continuity of the space observations. And as I told you, we are going to launch, OceanSat 3 and 3A, a series of 2 satellites, along with this radar satellite, which will be useful for many of the process studies which I just now summarized. These are some of the details. Some youngsters are interested to know about the specifications of these sensors. I will not go into details of that, but definitely ISRO has a commitment for ocean community to provide space-based observation, and it is up to the user community to develop newer products which can be used to boost the economic development all along the Indian coastal line. Thank you very much. Thanks a lot.
Yeah.
Thank you. Yeah.
Yeah. Go on, Dr. Smita.
Yeah. Thank you, sir. Actually, we couldn't see any questions in the chat box. But however, sir, from me, there is a question. It's not a question, it's an anxiety or this one. Actually, we, especially the people working in the marine living resources, are extensively using the satellite data. And we deal with the physical processes to marine, how the biology is responding. Especially, as you know, actually, biology, it is more important during the monsoon seasons or when the sea is very rough, like after and before the cyclone, or when the summer monsoon is happening in the Arabian Sea. And one of the main problem we face is the data gap due to cloud cover. So what is the way forward to tackle this issue, or how ISRO is approaching this? That's what the worry is.
Yeah.
And the question is.
Okay, so I think it's a good point which you have brought out. Especially for optical images, cloud cover is a real problem, and especially during monsoon season over both Bay of Bengal and Arabian Sea, we have persistency of clouds. So the polar observations, which is basically once in a day, or maybe there are multiple set of satellites which are now available. If you combine all these data sets, you can still get some observations, but I understand there will be large data gaps even in composite products. So we have been developing since long, where we have been discussing since long, that now the time has come that we have to put some of these ocean color instruments on our geostationary platforms, where now you have seen that with the kind of a system which we have, INSAT 3D or INSAT 3DR, we have a capability to observe Indian subcontinent with a temporal resolution of 15 minutes or so. So even if we have a geostationary, multi-spectral wave, sensor on the geo platform, probably at 500 meter spatial resolution to 1 kilometer spatial resolution, you will have a capability to observe these regions at least 30 minutes or so. And of course, they are all sunlight dependent. So maybe from 9:30 or 10 o'clock in the morning, you can get observations up to 3 o'clock in the afternoon. And then if you make composite products, because clouds are not static in time, so it's a possibility that some of these areas can be viewed in weekly and fortnightly composite images. So that is one way out to solve this problem. And this kind of things are being proposed. We had a lot of committees. There were joint committees of Ministry of Earth Science and ISRO, where this type of proposals have been floated. In fact, we were about to test this concept on our GISAT mission, which was launched on 12th of August. Unfortunately, the satellite could not be put in the orbit. Otherwise, we were having an opportunity to do experiments of this kind with this GISAT, and then probably that would have helped us in developing a full-fledged geostationary ocean color imager. Probably that is the only answer as far as the ocean color activity is concerned. Thank you.
Thank you, sir.
So, can I come
Yeah.
in? Yeah. Okay. Thank you. So, Dr. Prakash, very nice, very illuminating talk. If there are no more questions, I have one question for you, Dr. Prakash. See, this remote sensing data we are using for developing so many applications. So what is your suggestion, or what is your viewpoint on translating these applications into, in actionable impact to see on the ground? I mean, what is that gap, how it should be filled up?
Yeah. This is a very important question, Dr. Rashmi, and it is being discussed, debated. Unfortunately, what is happening, many of these scientific inputs which are coming by scientific fraternity, they are not reaching up to the grassroots level people, So the big gap today between the scientific community and the users is that you don't have a bridge between the users and science community. And that is not only in ocean sector, it is being felt everywhere. So now it is high time that we start involving the social scientists. There are multiple organizations in India, those who are working with the grassroots people. There are a large amount of NGOs, those who are working with, let's say, fishermen and other people. So I think we need to involve these people so that they can translate these products and services in the language which is understood by these people, because they are working with communities. So community level participation, scientists are not trained to do this type of communication with these people, but there are a set of people, those who are basically trained to, pass on this type of informative or this type of information to the communities. So I think this time has come, then we need to start discussing with our social scientists fraternity. There are organizations like this is there in Bombay. and there are many local level NGOs and all these people are working. So that is where I feel that we have to start interacting and do capacity building of these people so that they can better understand our products, so that we can reach to the grassroots level. That's what I feel.
Yeah, that's very nicely told about this one, that we need the community level participation. So if there are no more questions, let us all thank Dr. Prakash for his very illuminating talk. We all know that this concept of blue economy is so vast, and covering the entire gamut of components in half an hour time is a very, very daunting task. But I see that Dr. Prakash has touched each aspect very crisply and very concisely, like how ISRO's missions and the payloads working in multispectral, hyperspectral, and microwave domain are helping developing the different applications, and they're contributing to the nation's blue economy. So with this, thank you, Dr. Prakash. Thank you so much. And
it was a pleasure to have interaction with all of you. Thanks a lot.
Thank you. So Smita, can we go ahead with normal presentations?
Yes, ma'am.
So maybe you can give a small briefing about that.
Yeah. The first presenter is Samiran Mandal. I can see he is in the room.
Okay.
Samiran, can you upload your presentation, please? Yeah, actually, the time we have to limit it to 15 minutes. 12 minutes presentation and 3 minutes question answer session. You can start now.
Am I audible?
Yes.
All right. Okay, so good morning, one and all. So the title of my today's talk is Multi-Scale Subpollution Features in the Western Andaman Sea. And this is especially from the high frequency radars. So this is the status of the ocean current observations network in the Northern Indian Ocean. Until 2010, only the buoy network existed in the domain in the Northern Indian Ocean. So what is the advantage of the buoy radars? It is basically point source, and it can give us profiles and at regular intervals, obviously. But after 2010, the NIOT and MOEs, they have come up with a network of this coastal ocean radar network, and which has been installed at 5 locations in the Indian domain, and it covers the Gujarat coast and Tamil Nadu, Andhra Pradesh, Odisha, and the Andaman coast. So what is the advantage? So, and how they can be a revolution to the surface current observations network along the Indian coastline. So basically, they measure the ocean currents at every hour, and they have a spatial resolution of 6 kilometers, and they actually cover a range of around 200 kilometers from the coastline, which enable us to investigate the sub-mesoscale features in the coast, which is actually not possible from the available set of the satellite observations or from the model observation from the model simulation, as models couldn't those into the poor quality of the initial forcings in there. So since my talk is basically focused on the Andaman Sea, so some of the characteristic features of the Andaman Sea is this is the Andaman Sea. It has a very complex bathymetry in here, and similar to the Bay of Bengal coast, it also experiences seasonal reversal of the monsoonal winds. Then from the buoy, we can see these this is the seasonal reversal of the monsoonal winds, that is southeast monsoon and the northeast monsoon. Along with that, we can see the variations of the temperature as well as salinity profiles. We can see that mostly the profiles are constant throughout the year. There is no much variation in the data. However, it is interesting to note that below 80 meters, there is a huge temperature gradient, from 30 degrees to around 10 degrees, which may indicate towards the presence of the strong internal tides in the domain. So here are my objectives. So are these HF surface currents reliable enough? And how the tidal currents vary along the Western Bay of Bengal. So since there is a seasonality of the monsoonal winds, so if there is a seasonality in the surface currents as well, and are there any processes that are associated with it? And if there are any sub-mesoscale features, so we have investigated the dynamics of the genesis of the sub-mesoscale LEAD. So obviously, we have to prove the reliability of the HF radar. So firstly, the validation has been done on the tidal scale. Since we have a buoy here, and we have on the HF radar, we have chosen the nearest point with the maximum data coverage in this domain. So we have extracted the tidal currents here at both those locations from the buoy as well as from the HF radars, and we have seen that and validation has been made on the on the order of the amplitudes of the tidal currents. So it can be seen that the constituents, they match really well, they have a higher correlation of more than 0.95, and it can be seen that the M2 tidal currents are the dominating, followed by S2, N2, K1 and O1, as well as the shallow water constituents are also observed here, which actually matches with the model simulations in the earlier studies. So this domain has a semi-diurnal tidal regime, as because the F ratio is mostly less than 0.25, and there is a tidal variance is mostly around 10 to 50% in this domain, with the higher variance near the Little Andaman Island, that is the Hut Bay region, which actually indicates towards there is a complexity in the tidal flows in there nearby the island, or we can see with the 11-degree channel. So why it is so? So in that case, we are investigating the spatial variability of these tidal currents, mostly the dominating ones, like the M2 and the M4. So this has been the best representation of the tidal currents is through the tidal ellipses. So the major axis of a tidal ellipse, it actually represents the direction of the maximum tidal current. So you can see here that the tidal ellipses are mostly oriented into this 11-degree channel, and the major axis of the ellipses are higher near this region. It can be seen here also, from the semi-major axis. So similarly for the M4 ellipses, the tidal current amplitudes are mostly higher near to the coastlines. So for that, we have calculated a non-linearity index, which is actually the ratio of semi-major axis to bathymetry, and it shows a higher variabilities, or you can say higher values near shore region, the shallow bathymetry regions. So we can, and also there is a very special feature in here. There is a band of ellipses observed, like the blue ellipses in the red, blue, and then red. So there is a band that is continuing. This is actually the propagation of the internal tides, and this has been observed earlier in many studies from the SAR images or from the model studies. But this is the first time the HF radars could able to capture these things. So it is very important. It is one of the importance of these HF radars. So we have seen here there is a higher variance of the tidal currents, as well as the major axis of the M2 is also high. So why is it so? So in that case, we are looking into the diurnal variability, the variability of the tidal currents in a single day. And you can see that at the initial hours, the currents are going into this channel, then it is getting stronger, then there is a reversal time, then there is the currents are coming out, and then it is getting stronger, then there is again a relaxation time. So we have chosen a series of points around this Little Andaman Island, and we can see the propagation of the tidal currents. The currents are here from south to north, it is varying. So it is actually rotating, and then it is going inside the channel. So we can say that the currents, the tidal currents, they are actually skirting this Little Andaman Island, and they have maximum amplitudes near this 11-degree channel. And this intensification can be actually attributed to the convergence of the tidal waves and their interaction with this nonlinear interactions with the bathymetry as well. So next, since it is a multi-scale study, so we have done the validation on the daily scale as well. And so for the validation, we have chosen this buoy data, current observations from the buoy data. And since there is a shortage of, since there are limited observations of the currents, surface currents, so we have derived an algorithm. We have used an algorithm actually to derive the algorithm-derived currents, and which has mainly three components. That is the Ekman currents from the winds, the geostrophic currents from the visual altimetry, and the buoyancy currents from SST. With the validation with the buoy data, they show a good seasonality in here, in terms of both. However, there are a few gaps. So for that, we have done the validation at spatial scale with the algorithm-derived currents, or we can simply say it is satellite-derived current. And so it has also higher correlation, mostly 0.7, and the RMS is quite less. So we can, it has been now established that yes, the data sets are reliable. So is there a seasonality? Like we have seen here, there is a seasonality in the currents. So yes, there is a seasonality that exists. And the seasonal currents, these are mostly northwestward during November to February, and whereas it is it is southeastward during June to October. Is the mechanism behind this? So why the seasonality exists? So we have, for that, we have looked into two different parameters, that is from the winds, that is Ekman mass transport, as well as the geostrophic currents to look into this influence of the planetary waves, basically the Kelvin waves, coastal Kelvin waves, and the Rossby waves. So it can be seen that there is a point, and regional averaged time series data has been taken. It can be seen that yes, the correlation is very high for the with the winds, whereas very low with the geostrophic current. So we can say that yes, the winds are predominantly controlling the surface circulation pattern here. So next, with this seasonality of the currents, it is also observed that yes, the currents are going into the Bay of Bengal from the Andaman Sea during November to February, whereas the currents are coming from from the Bay of Bengal to the Andaman Sea during June to October. So there is a flow of the water masses which has been seen here, from February, March, and April. The water masses are actually flowing into the Bay of Bengal during November to February, whereas it is the other way around during June to October. So the seasonal reversal of the currents actually is playing a very important role, and that has and the local winds, they are actually they are predominantly controlling this circulation pattern here, and they are actually leading to the exchange of masses. So with the seasonal variation, we have also observed the presence of a lee eddy on the wake side of the Little Andaman Island. So this is some of the snapshots of the submesoscale anticyclonic lee eddy, and it is observed from 4th to around 8th. So this is the matured phase of the eddy, and this is the variation of the meridional component along this transact. This is actually the signatures of the eddy. So this eddy has it is very submesoscale feature, as because it has a mean radius of 9 kilometers, and it lasts for about 5 days. Also, the kinematics have been derived from here, like in terms of vorticity, divergence, and Okobo's parameter. All of them are negative, and they have negative values, and they actually characterize the anticyclonic eddy. So how this thing happened, what is the forcing parameter for the genesis, for the evolution of the eddy? So we have looked into the buoy winds as well as from the scatterometer winds, so from the SCATSAT1. So we have looked into the thing that there is a disturbance here in the winds. The wind speeds have gone, wind speeds are higher, as well as there is a slight change in the direction as well. So we are looking into the evolution mechanism in terms of the vorticity budget, which has the tendency term, that is the advection term, then the vortex stretching term, and the beta effect term, and there is a residual term. So for that, what we are doing, it is these are the variations you can see. So tendency term, it is increasing. There is no such variation in the advection term, but there are very positive values during this period of the eddy, and in the vortex stretching term, and this is the residual term. So again, to contribute to the residual term, we are considering the effect of wind stress curl. At the concurrent time period of this eddy, you can see there is a highly negative values of this wind stress curl. So that is actually so we can say that the negative values of wind stress curl as well as the vortex stretching term, they are actually playing an important role in the evolution of this eddy. So here are my conclusions. So this is one of the first studies to investigate the higher resolution surface circulation variability along the Western Andaman Sea using HF radars. So comparison with satellite-derived currents or algorithm-derived currents and BD currents, they establish the reliability of these HF radars at currents at multiple time scales. So M2 currents, they dominate among the others, and we have significant signatures of shallow water constituents as well. There is a skirting of one of the interesting facts is the skirting of the M2 tidal currents around the Little Andaman Island, which needs to be investigated from the models in the future studies. And since it has been unresolved yet, what are the forcing parameters to derive the circulation pattern here? So we have seen that the local winds, they predominantly control the circulation pattern, and they lead to this exchange of water between the Andaman Sea and the Bay of Bengal. Also, the submesoscale circulation features are also observed, and in terms of this evolution of anticyclonic lee on the of the Andaman Islands. So our recommendation is that, although we all know that the Andaman Sea is a poorly observed area, so this study presents the possibility of effective utilization of this limited area higher resolution surface currents from HF radars, And we will be getting, if it is possible, to assimilate these high resolution data sets into regional models to get much better simulations in the near future. Also, this study highlights the need to install such platforms like the HFADAS, ADCPs, and the mood buoys in these channels, which connect the two seas to monitor and understand the exchange of water masses and the mixing mechanisms thereby involved. So here are the few references. I would like to acknowledge NIOT and INQUIS for maintaining these observation platforms as well as making the data availability quite efficient. I would like to thank Dr. Glenn, Dr. Chena, and Dr. Venkatesan. Thank you.
Okay, there are no questions in the chat box. So maybe I will ask you a question. So you showed you showed an anticyclonic eddy in the leeward side of Andaman Sea. So is it a permanent structure or is it a seasonal kind of thing?
No, these are like synoptic features, we can say. So we have seen this eddy in August for a few days. So these are the submesoscale features actually that can be captured. That is actually captured from these HF radars. So that is the thing. So it is also possible that during some other time it is also evolving, but due to absence of data sets, we are not getting. It is it is not possible also.
Okay, maybe it might be a permanent feature also because of the changes. Okay, nice.
Possible. Okay. It is possible.
Okay.
Okay, so Dr. Samidan, very nice presentation where you have made use of the HF radar data, then the buoy data, and also the satellite data. In fact, the point that interests me is how did you make use of these data sets synergistically, in the sense that satellite derived currents are at 25 kilometer. Okay, your HF radar is giving you at a much better, higher resolution. So how can you make the comparison between the two data sets, which are at a totally different scales?
Right, ma'am. So for that, the algorithm, like satellite derived currents, they are available at 25 kilometers, and HF radars we have at 6 kilometers. So we have used the collocation methodology, particularly to validate on the spatial scale. And we have calculated the daily currents from both these data sets, and the daily currents from the statistics in terms of correlation.
But my main concern is that because you are losing out on many variabilities in the satellite derived currents, because 25 kilometer you are taking a single value. So maybe you can do some special decorrelation study using the HF radar that now that you have at 6 kilometer. So within the footprint of 25 kilometer, this is just my suggestion. You can just see what kind of a variability you see in the data sets. Okay. And one correction I would just like to make here is that actually this is not algorithm derived currents. There is I don't think there is anything called ADC currents.
Okay. No, ma'am. Actually, we have derived this. Later we came to know that SAC has also derived its own currents. So now we are actually trying to understand if it is also capturing the same currents or not.
All right. So
same variabilities or not. Yeah.
All right. So a SAC current is also making use of all the three data sets. So you can
just later we came to know actually.
Yeah. So you can make use of that and make an independent. Good work. So thank you. Thank you, Dr.
Thank you.
Yeah.
I think we can move forward with the next presentation. Shirin is there?
Yes, sir.
Okay. So Shirin will be presenting on phenology of coastal upwelling in the southeastern Arabian Sea. So carry on, Shirin.
Thank you. My presentation is visible?
Yes. You can start.
Okay. Good morning, all of you. Myself, Shirin Jadhav, MOS Junior Research Fellow. The topic for my presentation for Osicon 21 is phenology of coastal upwelling in the southeastern Arabian Sea. So, as we all know that Arabian Sea has unique environment in the world ocean due to the seasonal reversal of wind, that is southeasterly during summer and southwesterly during summer and northeasterly during winter. Under their influence, the circulation pattern reverses twice a year. Uh, the moderate winds blowing parallel to the coast favors upwelling along the coast, bringing nutrient-rich water, resulting high biological productivity in the southeastern Arabian Sea. Upwelling of the southeastern Arabian Sea can be indicated by the upward movement of the isotherm, surface cooling, and associated fall in the coastal sea level occur during the summer monsoon. There have been many studies done based on the to understand the policy mechanism and influential factors for the southeastern Arabian Sea upwelling system. So it is a complex in terms of the West India coastal current, river runoff, bottom topography, coastal orientation, etc. So this is my study area, Eastern Arabian Sea. Concentrating on my topic, that is the Eastern Arabian Sea upwelling system can be well compared to the Eastern upwelling system of the world ocean. There have been many studies explaining the variability in the processes in the long-term observation till now due to the change in climate. Few of them are intensifying, other systems are weakening in the intensity. However, there were no such attempts so far to explain the long-term trends in the Eastern Arabian Sea upwelling. So other knowledge gap in the area of research is understanding on the role of bottom topography and coastal orientation in the regulating the spatiotemporal variation. We adopted the local temperature anomaly method that has been computed as a coastal upwelling indices based on the average SST difference between the offshore and a box of similar size onshore along the same latitude. For that, we have taken the two parameter from the satellite data. One is sea surface temperature and chlorophyll. So daily SST data of 17 years from 2003 to 2019 taken from the Jet Propulsion Laboratory, NASA, with the latitude longitude latitude resolution of 0.01 degree. Also, chlorophyll data also taken out from the ESA, OCCI. In addition to the satellite data, we have taken the in situ data CTD profile collected on board F4A Sagar Sampada for 2 years, that is 2005 and 2009. So you can see in the figure, so we have 4 onshore boxes marked in the blue color and 4 offshore boxes in red color. So based on this, the lower boxes we defined as a lower zone ranging from 7 to 9 degree latitude, and middle boxes we defined as middle zone from 9 to 13, and the upper zone in the northern boxes from 13 to 17 degree latitude. And we further modified the upper zone into modified upper zone that is from 13 to 15 degree latitude. So we for each zone we have computed the daily LTA and distinguish them into anomalous year. So LTA climatology also derived for each zone and studied indices variation to show upwelling phenology. For in situ data, we have 3 methodology. One is LTA at 5 meter depth, D23 isotherm slope that has been computed to the selected transits. It is shown with the red dotted line in the map. Also D23 time series for coastal stations that are you can see in the image that red dotted fill circles are we have computed D23 time series for that stations, and we consider D23 isotherm as a proxy for upwelling rate. as well as surface plus section plots of temperature, density, salinity also taken out for the study. So this is the weekly climatology of the SST. So under the influence of energetic southwest monsoon, SST cooling is happening starting from the southern tip of India. So if you see the shelf region variation in SST from first week of June to first week of July, it is decreased by approximately 1.5 degrees Celsius. By August, SST pattern is completely changed with the colder water occupying the entire shelf. With the onset of summer monsoon, upwelling start from the southern tip of India with colder SST and propagate northward along propagate northward. So this figure shows the weekly climatology of the SST for a year 2003 to 2019. So from SST climatology figure from SST climatology, progressive cooling of ocean surface with each passing weeks can be observed from the June to August. This cooling began dispersing by September and will completely replaced by warm water in October. So weekly climatology of SST shows a seasonal progress in the upwelling in the southeastern Arabian Sea. Coming to the phenology part, left figure you can see we on the x-axis we have taken the period that is from May to September in days, and then in the y-axis we have taken the climatology of PLTA, and we put 0.3 as a threshold value of which we have defined we have considered as a upwelling indices. So 0.3 as a onset, and we have also a period between in onset and offset. So right upper two figures are lower and middle zone, below two figures for upper and modified upper zone, and middle figure is combination of these four figures. So concentrating on the first figure, lower zone, then we are getting that these upwelling indices are throughout the summer monsoon, they are we are getting above 0.3, and for the middle zone, if we see we are getting the onset. If we consider June to September month, we are getting onset at 7 July, and for the upper zone, we are getting negative indices. So from the SST map also, and from the LTA calculation, we got that onshore boxes are warmer than that of offshore boxes. That's why we reduced the width dimension of the box, and we settled the modified upper boxes, and we got 15 July as an onset date for the modified upper zone. And if we see the time span for the upwelling indices, lower we got 122 days, middle 77 days, and modified upper 84 days. But for the modified upper zone, extension is near to the coast only. Also for the lower zone, we are getting the maximum upwelling indices for the July month, followed August for middle, and September for the modified upper zone. These are the temperature section plots, zonal, that is east west and south north variation. So due to time limit, I will not go detail into it, but you can see from the zonal variation east west, that is for the June month zonal variation. So on the x-axis it is a longitude, and y-axis it's depth. So if we see Cape Kochi and Tikodi, we are getting D23 upliftment near the coast. As you go offshore, it deepens, and similar for Mangalore, Goa, Ratnagiri, but depth of D23 is deeper than this above 3 stations. And if we see the meridional variation, then we see from 8 degree to 13 degree in the May month. We are getting means D23 propagation from south to north, it deepens. So, and similar for the June month. So it's like northward propagation of upwelling is seen with according to the D23 isotope. So, and also we have done correlation analysis. So we have taken the satellite data and in situ data. So daily data we have correlated with the LTA, D23 isotherm and D23 time series. So while picking up the data and doing analysis, we were unable to correlate the satellite daily LTA with in situ derived LTA and D23 isotherm slope due to the non-availability data onshore offshore station for same day and non-uniformity in the distances between station. So, but the time series for the D23 for each coastal station given in the table with satellite derived daily LTA gives strong negative correlation for corresponding dates. So that as the LTA increases, the D23 depth decreases. So we are getting strong negative correlation for the corresponding station and corresponding zone. So the effectiveness of the LTA methodology to develop and describe phenology of upwelling for southeastern Arabian Sea is been well studied using associated changes in water column. Also, we have done the trends in the upwelling of the southeastern Arabian Sea. So you can see lower, middle, and upper zones in 3 figures above, and that is in y-axis it is SST anomaly, and x-axis 2003 to 2019 internal annual variation of SST anomaly is given. So if you see in the right column, last column, then the lower box is LTA, middle box is LTA, and upper box is LTA. So the lower region, lower zone, we are getting the somewhat positive upwelling intensity, and for the middle and upper boxes, we are getting negative trend in the upwelling. And last row figure, that is for the chlorophyll. So chlorophyll, we are getting for all zones, we are getting decrease in the trend. So these are my key points for work and presentation. The phenology of upwelling is derived based on the satellite data for different subregions of the southeastern Arabian Sea upwelling system. Spatial variation in the onset duration and the withdrawal of upwelling derived, and the interval variability is addressed from 2003 to 2019. Also, the acceptability of LTA method is verified. Trend in the process and the response in CHL along different subregions explained. Overall, the upwelling is weakening except for the southern region, while the CHLA is decreasing for all the 3 subregions. Thank you.
Thank you, Sharon. We don't see any questions in chat, but okay, I have a question regarding the trend. So yes, you are telling that you are saying that upwelling is decreasing in the northern region and increasing in the south. So
yes,
do you have any reason to, like, why is that so?
Actually, if we say actually it is due to the warming. If you see the images, wait. Actually, sir, here are if you see lower offshore box and lower onshore box. Here there is a 2015 and 2019. We are getting high SST for the same offshore and onshore boxes. This is due to the El Nino and IOD. These are the El Nino and IOD years. So so if we minimizing this signal, then we are getting a significant positive trend in the lower box CLTA, lower region.
Yeah, so you are telling that like during El Nino, like during El Nino periods or like other climatic events, upwelling decreases. That's
decreases.
What
yes, sir.
Okay.
Yes, sir.
So otherwise, it's increasing?
Yes, yes, sir.
Okay. Okay.
Dr. Bajish, I have one question for Shirin.
Yes, yes,
Okay.
ma'am.
Yeah,
Yes.
Dr. Shirin, very nice and very useful work you have presented.
Thank you.
Compliments for that. I have just one suggestion to you. Okay.
Yes, ma'am.
See, there is one paper by, you can just search it, by Shelly Patel et al. Okay, it was published in 2019 or 20 time frame. You can just search it. Actually,
Okay,
they have used a very long time series of satellite observations, and they have studied the temporal and the spatial variations in the monsoonal upwelling along the southwest and the east coast of India. Okay. So, I mean, it is on a similar line of study. So, it will help you if you refer that work. Okay, so
Yes,
that
ma'am.
you can, you can extend their work further. Okay.
Yes, yes, ma'am. Definitely.
So, just refer that work. It's a good work by using the satellite data alone. And now that you are also using satellite observation, so it will
Yes,
help you in your further studies. Okay. Thank you.
Thank you. Thank you, ma'am.
Yeah. Thank you. Thanks a lot.
Shall I come in, Bajish?
Yes, yes, yes.
Actually, I think the next presenter, Shubhasis Pradhan, is not in the room. He's absent, right?
Yeah, I don't see him. So maybe you
Okay,
can
then
continue with next one.
next presenter.
Yeah.
So, assume Google Wilson is ready.
Yes, ma'am.
And you can upload the presentation. So Google Wilson will be presenting on source and fate of anthropogenic particles in a transitional environment from southwestern India. So please remember your time is 15 minutes.
Yes, ma'am. Am I audible?
Yeah. And your screen is visible. Continue.
Good morning, everyone. I'll be presenting my work on source and fate of anthropogenic particles in a transitional environment from southwestern India.
Practice, I have to debug.
So this is the outline of my presentation. So coming to the introduction, the term plastic is actually derived from a Greek word called plastikos, meaning fit for molding. As we know, plastics are simply molecules linked together to form chains, and these chains are called polymers. And plastics are made from these natural materials like cellulose, coal, natural gas, crude oil through various processes like polymerization and polycondensation process.
Due to the Easter living.
Gokul, 1 second. Shirin
Yes.
is Shirin. Can you hear me, Shirin? Please mute your. Okay. Shirin. Shirin. Gokul, you can continue. Hello, Gokul.
Can you hear me, sir?
Yes. There was one more microphone that was on, so
Okay.
you can continue now.
Okay,
Yeah.
sir, no problem. So coming to microplastic, any piece of plastic that's less than 5 millimeter to 1 millimeter in size, there are two types, or there are two categories of primary microplastics, that's primary and secondary microplastics. When microplastics that are manufactured in size less than 5 millimeters for various industrial needs like microbeads for personal care products, etc. And secondary microplastics are those plastics that's mismanaged. These macroplastics break down by natural agents like UV radiation, mechanical weathering, etc. So coming to the effects of microplastics are often mistaken for food and consumed by these aquatic organisms. As we can see, there is a bioaccumulation of microplastics in higher trophic levels, which just shows that there is a trophic transfer of microplastic from the prey to the predator. It actually shown that ability to absorb pollutants just adds up to the ill effects of the microplastic consumption. These microplastics tends to develop biofilms and microbial colonies on its surface, which increase the density of the microplastic, which in turn makes this microplastic to sink and get settled in the sediments. These contaminated aquatic organisms can often consumed by humans when our dietary intakes has fish in them. And when we are consuming these contaminated fish, we are also ingesting microplastics as well. So coming to my objective, it is to study the occurrence and distributions of microplastics in different types of water samples and sediment samples of Kota Beach, and to investigate if submarine groundwater discharge can act as a possible pathway to transfer these microplastics from the continents to the oceans. So Kota Beach is considered for the study. It's in Udupi districts of Karnataka, and we consider this because the population density is very less as per the 2011 data. Of course, the population might have increased now. And we have collected sediment samples all the way from the high tide line to the sea at an interval of 5 meters. So we collected a total of 11 sediment samples and 4 water samples, which include 2 pore water samples, 1 seawater and 1 well water sample. So the flow chart of the methodology is, once we collect these water samples, we volume reduce using sieving of 0.3 micron millimeter and 1 millimeter sieves. And once it's sieved and transferred to a beaker, we'll use wet peroxide oxidation to destroy the natural materials. And it is subjected to density separation. So all these plastic particles and plastic particles get floating. And once this floating material is transferred, again sieved and transferred into watch glass and taken it for visual identification and FTIR analysis. When it comes to sediment, one extra step is like we'll do a primary density separation so that whatever the floating particles is there in the beaker is transferred and is taken for natural destruction of the natural materials, So coming to the water samples, we found a total average abundance of 36 pieces per meter cube, and we found that the highest amount was recorded at open well at a 48 pieces per meter cube, and lowest is in pore water at 35 meters from the high tide line at with an abundance of 24 pieces per meter cube. And as we can see that the locals wash their clothes in the well seal, so that which accounts for the higher amount of microplastics in the open well. But when we come to pore water, there is relatively less number of microplastics, and which one of the major reasons is because it's a closed environment and there is no direct exposure to any anthropogenic activities. Coming to the categories of microplastic that we have recovered, for our surprise, we only recorded fibers, and foams, films, fragments, and pellets were not recorded in the study. And one of the most possible explanation is that we know that rivers are the major carriers of microplastics to the ocean, and there is no major rivers or any other riverine inputs that can flush these microplastics from the hinterlands or the inlands to the sea near our study area, which means the most of the microplastics that we record there are of Aeolian origin. And one of the reasons for relatively low microplastic amount in this beach is because it's very less populated and it's not very tourist attracted beach. So the activity in this beach is very less. When we look at the size fractions from the water samples, we found that the smaller sized fractions of 0.3 to 1 millimeter were greater, which accounts for 55.56%, while the larger sized microplastics of 1 to 5 millimeter accounts for only 44.44%. One of the reason is like, since it's a coastal region, the high UV radiations coupled with mechanical weathering results in breakdown of these larger plastic particles into smaller fractions. When it comes to sediment sample, we found that the average abundance is 31.5 pieces per kilogram of sediments, and the highest amount was on the high tide line, 0 meters from the high tide line, which is 52.5 pieces per kilogram, and lowest is recorded at the 50 meters from the high tide line to the sea. So the highest amount of microplastic recorded from the high tide line and the lowest at 50 meters indicates like these plastics are washed by the waves and get deposited during high tides. Coming to the category of microplastics from the sediments, we recovered that there are 2 types of category we have recognized, which is fibers and fragments. Fibers still accounts for the majority, making up to 90.78%, and fragments making up to 9.22%. And similar to water samples, here also we have noticed that the smaller sized fractions accounts for 54.74%, which is greater than the larger sized fractions. And one of the main reason is that of UV radiation and abrasion of the sand particles by the waves and all these actions results in breaking down of the plastics into smaller pieces. So coming to the different colors that we have identified, the majority was transparent, followed by black, orange, blue, white, brown, and yellow. Why identifying colors of microplastic is important is that it actually provides information on the source of microplastic. Since most of them that we have recovered were transparent microplastics and mostly fibers that results that it's of fishing lines and cloth fibers accounts for the second more abundance of plastics that is recorded, followed by packaging materials. These colored microplastics are important as we know most of the marine biota are visual predators and they often mistaken it for food and ingest these microplastics, which can affect their health as well as if we human community or the coastal community that depends upon fishers, when we consume them, it's going to have ill effects to our health as well. The most significant part of this work is, as we know, the submarine groundwater discharge act as a pathway for the emerging contaminants to reach the oceans. So the record of these microplastics from pore water, which is 1 meter below the sediment surface, indicates that these fibers or the microplastics can tend to sink or vertically migrate in the beach sediments and can reach the shallow aquifers, and submarine groundwater discharge can act as a possible pathway for the microplastics to move from the continents to the oceans. So this is something that is widely overlooked, that what if that submarine groundwater discharge can act as a possible pathway for these microplastics to enter the oceans. So coming to the conclusion of the study, that it shows that the transitional environment of Kota is contaminated with microplastic. We also recorded both in sediments and water samples that smaller sized microplastics are dominant than the larger sized particles. Fibers accounts for the majority of microplastics that is recovered, and since it's mostly transparent, we know that it's from that fishing activity because of the fishing activity in the region, and this may be a result of the fishing lines. And following that, the major source of MP is in that entire region is due to fishing activities and washing clothes by the locals near the well site is the reason why this distribution of microplastics can be seen in the Kota region. That would be it. Thank you so much for your time.
Excellent.
Dr. Smita, Dr. Bajish, are there any questions? If no, then I have a question for Dr. Gokul.
Yes, ma'am.
Yeah, actually, I must say that it's a very, very pertinent and extremely useful work that you have carried out. Okay.
Thank you, ma'am.
And I have one suggestion as well as I have a question also. Okay.
Yes,
so
ma'am.
You mentioned that this microplastics actually the important thing is to understand the pathways of these microplastics, right?
Yes, ma'am.
So what led you to talk about this submarine groundwater discharge? Why microplastics cannot come from the surface runoff, and why from SGDs?
Ma'am, actually, we have literally literature that proves that all these surface runoffs, as well as that riverine inputs, aeolian origin, all these are actual pathways for the microplastics to enter the ocean. But as we look at the literature or whatever the studies that has been carried out, there was no literature on act of like submarine groundwater discharge may act as a possible pathway for the microplastic to enter the ocean, because this is widely overlooked at this point. So this is a preliminary work. We have carried out the similar sampling in more beaches. We'll be analyzing. It's currently under processing. So we'll have a much clearer idea once all those samples will be processed.
Right. Very nice. Thank you. Thank you, Dr. Gokul. Thanks for a good presentation.
Thank you, ma'am.
So we will go to the next presentation. It's by Gokul Walson. Since Gokul is ready. And the title of the presentation is Sustainable.
Ma'am, I'm sorry to
Yes.
disturb. I just finished my presentation right now.
Sorry. Yeah. It's Arun VS next.
No, Guru Prasad, sir.
Sorry, I think something is missing.
Guru Prasad.
Yes, Guru Prashant. It's sustainable management of shoreline near Mahabalipuram. Am I right?
Good morning, everybody. After many introductions, finally I am Guru Prasad here to present my study on sustainable management of the Mahabalipuram shoreline. First of all, my many thanks to Dr. Rashmi Sharma Madam for chairing this session. We have seen your exemplary work with ISRO, and we are very thankful that you have shared your valuable time with us. And I also thank Baji Sir and Smita Madam for co-hosting this. With your permission, ma'am, shall I start presenting my presentation?
Yes, sure.
Thank you.
You are able to see the presentation, ma'am?
Yes, it's visible.
Yeah. Good morning, everyone. My presentation is on sustainable management of shoreline near Mahabalipuram coast. Many speakers before me have spoken about a lot of open ocean process, their models, etc. Mine is going to focus more on the coastal environment, and my research is more towards field studies and how we can use the inputs that we get from this field studies into modeling and for subsequently management of the coastline. Many of us have very limited idea about the shoreline and the coastline of India. So if you take the mainland and the islands, Andaman and Nicobar, the Lakshadweep Islands, there are a vast variety of coastal landforms. Some of them I have tried to capture in sort of an image over here, and they can vary from wide, nice beaches to rocky shores. They can have offshore spits. So there are many different forms of these coastal landforms. So each one of them cannot have a set rule for protection or management, and it has to be site specific, and it has to consider all the stakeholders in that particular coastal area. Two predominant ways in which this coastal landform get affected is very well known to everyone. One is called the longshore current, which is causing the littoral drift in the longshore direction. The other is the cross-shore sediment transport. This, acting by the waves during storms, etc., changes the beach profile, and the longshore currents in turn changes the shoreline form. So these are the two simplifying assumptions in which we try to study a limited coastal structure. Now, with the advent of a lot of satellite imagery and high resolution images, we are now coming into some sort of understanding that these complex structures can be actually looked at as simpler cells. These are often called as sediment cells, wherein each of them interact with one another in a limited spatial and temporal scale to maintain an equilibrium. A good understanding of this will help us in our coastal management. So whenever we say sustainable management, what we mean is that we should not cause more harm than what it actually is there. We have to understand the reasons why certain things happen and also try to propose solutions that will in turn not cause more damage or will not cause more harm to that particular coastal landform. Hence, this micro level studies are also as important as we do for macro studies. So a typical way of how we go about this coastal management has been presented in literature by Southern and Narain. This is the source which I am quoting over here. How systematically we have to go ahead and try to ensure that we plan a good management system. Even in India now, the coastal regulation zones, the environmental clearances, and also the resilient structures in coastal areas to deal with climate change, etc., are gaining a lot of importance. And one of those important aspects in understanding all this is the morphological modeling. So this morphological modeling is a very, very important component as it forms a link between what the decision makers need and what the scientists have understood. So my studies have been focused towards this aspect. Why is this such a challenging topic? Why is it that we are looking at it in such depth? Is because the range in which these coastal morphologies are affected, both in temporal and spatial scales, are just simply too wide. Right from smallest size of sediments to macro big waves, all of them have an impact. In addition, we also have human interventions. We also have these littoral drift. We have storms. We have waves. So many things act at different temporal and spatial scales and cause a morphological response in these coasts. And this results in erosions, accretion. It also results in scour, breaching, etc. So it is not a one size fit all that we can go and look at in terms of coastal zone management. So my location here is the very famous Mahabalipuram shore. It is historically very, very significant, one of an UNESCO notified locations. And the idea behind selecting such a location is because here we have taken up certain coastal protection measures in the past where not much studies have been conducted. It was taken as an immediate measure to protect the structure. In fact, even during the tsunami, many people have seen that when the seas receded, they could see a lot more structures in the deep seas. Even NIO Goa has taken up a lot of underwater studies to locate the other temples that have been submerged due to sea level rise and erosion. So a study in such a location would give a good template for us in future also to see where this erosion problems are there and come up with very sustainable solutions. So I have taken up this coast of Mahabalipuram to do my studies, and I have taken up current measurements, waves, near shore bathymetry. I have measured sediment size and a whole lot of very micro level measurements have been carried out over different seasonals. Like this coast experiences both southwest monsoon effects and also the northeast monsoon effects. So I have collected over different seasons to compare and contrast what happens. This is a very simple study you can see from basic Google Earth images itself, how with different seasons there is both accretion and there is erosion, and how it is different on either side, the northern and the southern side of the beaches. In such a small environment, we are able to see the vast differences in the cycles, the seasonal cycles. So this, I have captured these photos during Cyclone Nivir when I was undertaking studies over there. You can see how an entire village has been forced to shift all their boats and other things to prevent seawater from entering theirs, and also how devastating these effects can be. And this is again some photos from my study where we can see a very, very significant erosion when the monsoon season begins. So these are the different studies I have taken up. I have measured the currents on all three sides of this existing particular shore protection measures. I have tried to measure the waves, the beach profiles, and also conducted suspended sediment concentrations, turbidity variations, etc. All these parameters that I'm mentioning here, for people who do not know about modeling, they all form as inputs to the coastal modeling softwares. So a good tuning of these softwares with correct measured values will help us understand the model response better, rather than going for assumed values or usual thumb rule values. So these are some of my distinct observations, I can say. That these local winds had a very, very significant impact where they were peaking during the noontime and causing changes. And also the current measurements differed between northeast monsoon and the southwest monsoon. The speeds were different, and even the beach profiles. One of the simple thumb rules people would say is whenever there is an erosion, you will find an offshore bar. So that we could find only during the southwest monsoon season and not in the northeast monsoon, which means that something else is happening during northeast monsoon. So similarly, the wave heights, the wave periods, all these are very critical inputs, and all these measurements prove that they don't remain the same. We cannot assume that both the southwest and the northeast will have similar impact on the shoreline over there. And also the sorting of sediment grain size, etc., are very, very critical inputs, because when you run a model and tune the values of the model, we need to know how the sediments kind of separate out. Where do you find the fine sand, where you find the coarse sand, because that is what will influence your results. So after studying both the northeast and the southwest monsoon, we could find that there is significant deposition in the near shore region. And it is very important that we conserve this sediment and we don't let this sediment loss continue, because if we start losing the sediment, then the accretion of the beaches will subsequently decrease as the years go by. So a complete shoreline analysis from the past to the present is right now being carried out to see how much of sediment have we lost due to unsustainable sort of coastal protection. So always in coastal protection, we have both the soft and hard engineering measures. The earlier thought process was always towards hard engineering measures, but now a lot of studies have come towards soft engineering measures, stabilization of dunes, planting, plantations, beach nourishments. But whatever the measure is, the monitoring is the most important because it gives us the feedback. And one of the new recent and also proving to be successful is the offshore breakwaters, which consists of bioshields, wherein it also acts to promote the local fishes and corals, etc. This has already been successfully studied by some of the IIT ocean engineering scientists. It has proved to be very effective. So I have suggested that we take up a sustainable solution of this coast also, and I am doing the modeling studies, etc., to see how successful it would be. My reference has been Turner et al. 2005, who has done similar studies for a submerged offshore breakwater. This also has a similar effect of breaking the waves well before they reach the shore and reducing the wave energy, in turn leading to sediment accumulation. So why we are proposing this in Mahabalipuram is because we already have offshore breaking of these waves. So those areas can be developed with coastal bioshields, and then we can see if these waves will in turn lead to sediment deposition. As I showed you in the previous slides, it is important that we conserve these sediments. So I have used Mike 21 lit pack model, which has a lit line, which is a numerical model. Using all the inputs from the field, we tried to simulate how the shoreline would change if we were to build an offshore structure. And the modeling results are also proving the fact that if we have a submerged offshore structure, then we can see an advancement of shoreline, as in these sediments can be conserved. So this is the brief study I wanted to present to you. I understand there is a time limitation, so I would be happy to discuss with the interested people at a later time whenever you can connect with me. So I thank the chairman and the coordinators for this opportunity. I await your questions. Thank you, ma'am.
Dr. Bajish, are there any questions for Dr. Guru? I think he's not audible.
No, madam. Actually, there is no questions in the chat box.
Okay. So, Dr. Guru, one comment from my side. Very nice presentation, and I see that it's a very useful presentation in the sense that it is indeed the call of the hour, because our coastal zones are so much vulnerable to so many activities. But do you have any, in your work, do you collaborate with any other institution, or is it a completely in-house activity?
Actually, ma'am, I'm not yet a doctor. I'm a research scholar at IIT Madras Ocean Engineering Department.
All right. Okay.
So this is a part of my PhD studies. I am taking measurements at different sites. So I wanted to present one particular site at least so that people can get an idea about how it is site specific. We cannot have a one size fits all basically.
That's right. That's right. Because given that so much of spatial and temporal variabilities exist, so definitely one model will not fit all. So, but just one suggestion I would like to give you, because you are pursuing your PhD. See, nowadays we have very high resolution satellite data available. Okay, so you can make use of that satellite data, and there are many researchers who have used that data for studying the erosion, coastal erosion, for accretion, all that aspects. So maybe those kind of input will help you in your studies. So, and these data sets are now, I think, easily available So
Yes.
it will help you for your
Yes.
research. All right,
Yes.
all the best. And
Thank you, ma'am. Thank you, ma'am.
Yeah, one quick question, Guru Prashant, from my side. Actually, we know that this area of Mahabalipuram is very sensitive, and the effect of tsunami was very drastic there. So, how often you are observing the area? So, what is the temporal resolution for the monitoring of the area?
Actually, we have a very long-term data on beach profiles already. PWD Tamil Nadu has been taking it up since last 10, 12 years. They have the data over there. So what I am more focusing on is how they change over seasons, because they have focused only on the accretion erosion part of the beach profile. So, but what I am focusing on is how the cell in turn acts, whether there is bypassing around the structure, whether we are losing the sediments over a period of time, whether there is a permanent retreat of the shoreline. So those sort of studies I am doing. I am going there almost on a monthly basis to measure the shoreline and also take my measurements. But the detailed measurements are reserved for the three-way seasons: northeast, southwest, and the fair weather season.
Okay.
Okay, Mr. Guru, one question from my side. Like you are looking at the like possibility of a submerged breakwater. So, have you also looked into like the possibility of natural breakwater? Like maybe already there are sand depositions
Correct.
there.
Actually, 1 kilometer offshore, there is already some submerged rocks and other things which are acting as a small sort of, you can say, a submerged breakwater kind of effect. But that is not still good enough to protect this particular location. So I'm planning in the next fair weather season to cover a large area. I'm also trying to take up some seabed geophysical studies and find out if we can come up with bioshields in that location, so that we can preserve the sediment and prevent them from getting pulled back into the sea.
Okay, thanks for your presentation. Okay, maybe we can move to the next presentation.
Thank you, sir.
So Arun is there. Arun, we are. I think Arun.
Yes, Arun is here. Arun is here.
Oh, okay. So
Am I audible?
Yes. Okay. So you can load your PPT. So next presenter is Arun VS. So he is presenting on spatio-temporal variation in the current pattern associated with oceanic southeastern Arabian Sea.
Yes.
So Mr. Arun, you can present your.
Okay, so a warm good morning to all. My name is Arun VS. I am working in CMLRE. I'm a PhD scholar working under Dr. Smita. The work that I am going to present is the spatial temporal variations in the current pattern associated with oceanic southeastern Arabian Sea. Coming to the background of my work, we all know that as per winds, the Arabian Sea is characterized by reversing wind patterns, resulting in summer and winter monsoons. The transition phase of these monsoons are comparatively inactive: fall intermonsoon during October and spring intermonsoon during April, May. As per sea surface temperature, we all know that the sea surface temperature increases towards the May, and with the onset of summer monsoon and with well mixing and all, the sea surface temperature reduces. It follows that pattern, and driven by the combined effect of alongshore wind and remote forcings, the coastal upwelling dominates in the southeastern Arabian Sea during summer monsoon and remains biologically productive for only that season, while the northeastern Arabian Sea is biologically productive throughout the seasons, with the addition of convective mixing enabled by northeasterly continental winds and oceanic upwelling during summer. And coming to the study area and the significance of my work, the study area is southeastern Arabian Sea. Only limited information is available for the open or oceanic southeastern Arabian Sea, other than the dynamics of Tweedies, Lakshadweep High and Lakshadweep Low, occurring during summer monsoon and spring intermonsoon. intrusion of low saline water from Bay of Bengal during winter, the positive wind stress curve, and like that, which are well explained for the oceanic Arabian Sea. And coming to the shelf region of the seas, it is also well explored region, having a large amount of accessible data compared to the oceanic region. And this oceanic region is a unique area, including a part of Chagos Lecadio archipelago and experienced by the reversing surface winds and reversing currents. And the biological understanding is also limited in the oceanic Southeastern Arabian Sea. And the significance of this region identify are the presence of strong subsurface chlorophyll maxima, rich coral present in the island system, abundance of tuna resources, spawning, breeding ground of tuna, like fishes, etc. Apart from these, the oceanic Southeastern Arabian Sea remains unexplored regarding the variability in its processes and the forcing that regulate the ecosystem dynamics. In the present study, we are doing an analysis that is regarding the variability present in the oceanic region of the Southeastern Arabian Sea and the influence of island mass in the dynamics. 4 locations were analyzed in our study: a region within the island cage, that is the CB02, and a region which is east of the island system, a region which is of the west of the island system, and we selected a particular location within the island system, but it has no zonal obstructions. And the data that was used was wind from SCAT, an ADCP which was deployed at the west side of the Agadi Island, NAOT moved buoy currents, surface currents from Copernicus globe current, and sea surface height, which was occurred from global ocean physics reanalysis marine Copernicus. First, we analyzed the current structure in the enclosure of that islands. And what we understood was that as it is an island region, it is having shallow region. So the tidal effect is very much significant within that current. And for further analysis, we used Morlet wavelet analysis. From that, what we observed was that it was having a 8 to 16 day mode of oscillation during the months of January and February, and some high frequency fluctuations also. But due to the limitation of this ADCP that was moved from January to May of 2019, we selected an NIOT buoy, CB02, which is located at the east side of the island Agadi, just like inside the enclosure. And from that, what we observed was that throughout the year, the current is dominant in the south direction. And by using the Morlet analysis, we observe was that the similar patterns that are present in the west side of the island from the ADCP is also present in the east side of the island, that is within our NAOT buoy data. And some more high frequency fluctuations are seen in this data. So in order to see the forcings that are more controlling the currents, we selected the wind and the sea surface height. From the wind, what we observed was that the wind is also dominant in the southward direction throughout the year. So it is favoring the southward direction of the current, we can say like that. And from the wavelet analysis of the wind, we can see that the wind and the currents are not that much matching, but it is matching with the variations or oscillations present in the sea surface height data. So from that, we can say that it can be remote forcing that is controlling the oscillations within our current in the enclosure of that island. So in order to see how this remote forcing is working, we selected 2 locations, that is before and after our island system. And this is the sea surface height before and after the island system. And from this, what we observed is that after the island system, the oscillations, that is oscillations in the sea surface height is more during the months or the first half of our year than in the before region. We can see that in the second figure, it is more, it's like going into the more time period, more time it is going, that oscillation. So for that, we also analyze the surface currents and the wind before and after the island. And before the island, the current is showing the same structure as that of our West Indian coastal current, with the wind showing summer monsoon features. The current and wind are showing additional variabilities that do not match, which can be remote forcing. That is established idea because it is in the path of our Rossby waves that is propagating from our Indian region. And the current and wind pattern after the island system, it is also having low frequency variabilities, and that is also extending into the mid of the year, which can be the influence of island systems on the Rossby wave as it is lying. It's in its trajectory, which need to be further studied. And we also selected a point which is having no obstruction, no zonal obstruction as that of the island system. And high frequency variations are low in this compared to the region that we observe that is within our island enclosure, which can be due to the island mass alignment and coastal effects. The remote forcing is more evident in the currents in this region, which is having no zonal obstruction, and that can be verified using our sea surface height data. And this was also verified using NIOT buoy data AD04. And the key points that we observed from the study is that the surface current pattern in the oceanic southeastern Arabian Sea consisting of island system is dominant in the southward direction. The wind is favoring the southern movement of surface currents. The current within the enclosure of Lakshadweep Islands do not align with the wind variability, but is in good agreement with sea surface height, which implies the remote forcing on currents. The remote forcing along western and eastern part of the island system is comparable. However, change in the duration of forcing observed east of the islands is possibly due to the topographic variation in the island system. And the variability in the island cage region is observed with more high frequency oscillation compared to the oceanic region. And from observing the sea surface height or the climatology, we can see that with while the Rossby wave is coming in contact with the island system, there seems to be a shift in the phase velocity. That is what we observed, and that also needs to be further studied. Thank you.
Thank you, Arun. So we don't have any questions in the chat section, but ma'am, you have any questions?
I don't have a question, but just a suggestion for Dr. Arun.
Okay.
Good presentation, Dr. Arun. And I have just one suggestion for you. See, this 8 to 16 day variability that you have seen in the current, that is at a point location using the buoy observations, okay? Right?
Yes, ma'am.
Yeah. And actually, you're trying to correlate it with the satellite sea surface height data set, and then by computing the wavelet analysis, by carrying out wavelet analysis. Just be little careful because satellite data are at a very, very coarse resolution. Okay.
Yes,
and also, I saw that there is not much of a variability seen in the wavelet of the sea surface height observation. So, what I would like to suggest you is you go for a very, very high resolution modeling effort. Okay. That will help you in diagnosing the cause of this 8 to 16 day variability in the currents. Okay. I'm not discouraging you from using the satellite data, but you keep this also in your research work about this high resolution modeling. Okay.
Thank you.
And one more point which I would like to say that this satellite observations also, for your information, in another 1 or 2 years, we are going to have a very high resolution sea surface height observation from space mission, which is called as a SWOT mission, Surface Water Ocean Topography NASA mission. So there you will get 2 to 3 kilometer of resolution, the sea surface height measurements. So that will help you in your studies. So keep an eye on that instrument as and when it is launched. Okay?
Thank you, ma'am.
All right, thank you.
So maybe we in our schedule we have a tea break. So we,
All right. So we will break for 15 minutes.
yes, maybe
Yes,
if,
ma'am.
okay, yeah, we are on time, so we can meet around 11:45.
All right. Thank you.
Okay.
Thank you, ma'am. Thank you, Bajish.
So Rashmi ma'am is there. Okay.
Yes, Dr. Bajish, can we start?
Yes, yes.
All right.
Okay, now we are going to towards the quick presentation session. So here there is no question answer session as such for because of the time is only 5 minutes. So if the presenter finish before 5 minutes, maybe we can ask 1 or 2 questions. So the next presenter, according to the schedule, is Giridhar. Giridhar, are you there?
Yes, sir. Good morning, sir.
Good morning. So can you share your screen, please?
Sure, sir.
So Giridhar, it is 5-minute presentation, so keep your timing, please. So Giridhar will be presenting. So your topic has changed, I think. So okay, wave transmission through flexible and rigid vegetation.
Yes, sir.
Okay, you can start.
Sir, good morning all. Myself Giridhar, research scholar from Andhra University. My presentation on wave transmission through flexible and rigid vegetation. Because of lack of time, I'm just skipping to objectives. As we all know, the severity of coastal erosion. One of the countermeasure of coastal erosion is vegetation, and that's my topic for this. And these are the vegetation species. I mean, major mangroves species are these are the things. And when it comes to reality, this will be, I mean, these mangroves will be like this. And and with mangroves and without mangroves, if this is our cost, if this is our structure, and with mangroves will be like this, and sea rise will be up to here. Without mangroves, your wave height is up to here. And coming to objectives, it's to study this. I mean, the main objective of this study is the wave transmission for different vegetation models, like rigid vegetation with roots, and flexible vegetation, to measure the frictional resistance affected by the rigid vegetations, to study the Darcy friction factor with Reynolds number. And the mechanical characteristics of vegetation have a considerable effect on the resistance to flow of water. And the quantification of friction factor in study uniform flow of primary interest, and has a practical relevance as far as long waves are concerned. And methodology and experimental investigation, we are having test facility, and we are having a wave maker of 1.5 meter by 1.5 meter, wave flume of 1.5 meter by 1.5 meter by 45 meter long. And these are the models which we prepared, and replica for original things. And this is a flexible vegetation model, and this is rigid vegetation model with roots, and we tested without roots also. And these are the pictures of while doing our experiment and test facility. And we are having this wave flume, and of length of 45 meter across, 1.2 meter wide by 1.2 meter depth, and wave generator. And it's a piston type wave maker, electromechanical piston type computer controlled wave maker. And we are having data acquisition system, and this can produce only regular waves. And this setup is at Andhra University, and this is a computer control panel. And I'll show the this is a data acquisition system, and we are getting the signals from the wave probes, which we connected, which we arranged at the middle of before our model and after our model, so that we'll get the wave transmission. And this is the schematic diagram which we placed this wave probes And this is wave maker. We placed this wave probes before model, and this is our model, and we placed after the model, so that we can get the wave transmission. Yeah. And this is how wave generates and wave transmits. So that's it. And results and discussions. It's I mean, cost effective, sustainable coastal defense, the vegetation, waves and erosion. Yes. Yeah. Coming to summary and conclusion, wave transmission is found to be decreasing with relative water depth for flexible vegetation for H by I. One. Conversely, transmission increasing with relative water depth for rigid vegetation. Similarly, this was observed for H by V 0.667, 0.40, and 0.267. Maximum variation RU by H is 0.2 for all values of H by I. And predictive equation also mentioned in that for transmission coefficient were proposed for rigid with roots and flexible vegetation also. Darcy friction factor decreases, friction factor F decreases with Reynolds number in range study up to 3 into 10 power 5. The present study covers the range 0.5 and 1.5 in 10 power 4 to 3 into 10 power 5. Comparing with previous results and beyond the range of earlier investigation. Thank you.
Ma'am, you want to comment something? Hello?
It's fine. He has presented the experimental results, but actually he should have. It's just a suggestion that what in one line, if he can just tell us what was his exact finding, so that will help us. I mean, yeah.
Ma'am, we find the wave transmission before and after the flexible, I mean, vegetation models, so that whether
so you are proposing that flexible vegetation will be helpful.
Yes, ma'am.
Coastal management, right?
Yes, ma'am. Yes, ma'am.
All right. Thank you. Yeah.
Thank you.
Okay, now we can go to next presentation. So Hari Krishnan is there. Hari Krishnan R. Okay, maybe he's not there. Vasudevan Shankar.
Okay. Okay. Bajish, I got a call from Vasudevan Shankar.
Okay.
Due to some internet issue, he is unable to connect now. He is trying. Maybe we can go for the next presentation and later he can be considered.
Yeah. Maybe at the end he can join it. Okay. Yeah. So next one is Arjun S. Nair.
Sir, yes, sir.
Okay, Arjun. So you can share your slide now.
Yes, sir, I will share it.
So Arjun will be presenting on modulation of boundary layer parameters in association with tropical cyclones over the Bay of Bengal. So, okay, Arjun, you can carry on.
So I think that my slides are visible to all. Is it so?
Yes.
Okay. Good morning, all. So I am Arjun S. Nair, doing my final semester masters at Sri Krishna College, and also I am a project student of IIT Pune. Then now I am going to present a part of my MSc dissertation here, and which is being represented as modulation of boundary layer parameters in association with tropical cyclones or the Bay of Bengal. So directly going to the introduction, we could see that tropical cyclones are really the intense atmospheric vortices which develop over the warm tropical ocean. And we are taking the daily data of boundary layer parameters SHF, LHF, momentum flux, wind speed, and rainfall, OLR, and ABLH also. And here we are mainly analyzing the climatology and also the majorly we are analyzing the anomalies of these boundary layer parameters, which means 5 days prior and after cyclone and also during the cyclone. In 3 monsoon seasons, which means the pre-monsoon, southwest monsoon, and the post-monsoon season. Here we are neglecting the winter season because the number of tropical cyclone occurrences in the winter season is very much less. So here we are also tracking the locations of tropical cyclones over Bay of Bengal during our basic period of study, which is from 1979 to 2018. So directly go into the results and discussion. You could see the track of TCs, and the track of TCs has been taken from Joint Typhoon Warning Center. And you could see that from the figure, it's very clear that the major number of tropical cyclones is occurring in the post-monsoon season, but the least is occurring in the case of southwest monsoon season. And in the case of southwest monsoon season, you could see that the tropical cyclones are occurring along the east coast, while in the case of post-monsoon, you could see that it is overall distributed. In the case of pre-monsoon, you could see that the tropical cyclones are majorly concentrated in the central Bay of Bengal. And next, we are going to the major core of my project, that is the anomaly results. And in the anomaly results, you could see that the columns are represented. The first column represents before 5 days analysis, and second column represents during cyclone, and third column represents after 5 days. And the first row represents pre-monsoon, second row monsoon, and the third row represents post-monsoon. And in the case of momentum flux, you could see that the tropical cyclones are really triggering an increase in the case of momentum flux during cyclone in all seasons, with pre-monsoon is having the maximum number or the maximum increase in the case of momentum flux. And you could see that the post-monsoon is showing least number of observations. That's also a great credit to my project, because we know that in the case of post-monsoon, the level or the vertical wind shear is very much less. So there the momentum flux should be decreasing. So next, we are going to the case of SHF, which means that sensible heat flux. Here also during cyclone, you could see that the sensible heat flux is decreasing. Sensible heat flux decreasing, which means that an increase in the sea surface temperature, and also there is a huge chance for cyclogenesis to occur. But the interesting factor what we are getting is that after 5 days in all these seasons, you could see that there is an increase in sensible heat flux. And a similar pattern is being done in the case of LHF also. You could see there also during cyclone, the LHF is being decreasing. But the major interesting point in the case of LHF, we could see that in post-monsoon, before 5 days and after 5 days, it is being increasing, or the TCs. TC means tropical cyclones are really triggering an increase in the case of LHF before 5 days and after 5 days of post-monsoon. And next, we are going to the case of outgoing long wave radiation. And majorly, we could say that the tropical cyclones are really triggering a decrease in OLR, but you could see interesting that in monsoon it is increasing. So that's the major reason for having the least number of tropical cyclones in the southwest monsoon season. You could see in the post-monsoon and the pre-monsoon that even during the cyclone or before 5 days or after 5 days, you could see that OLR is being decreasing. And next one is the rainfall. As expected, we are getting the major results from monsoon. You could see that one of the interesting facts is that in central India, you could see that central India is having the least rainfall even during the time of cyclone. And during the time of cyclone, you could see that in all seasons, we could see the major number of rainfall. And when it comes to wind speed, we know that wind speed is a measure of TC intensity or tropical cyclone intensity. So our expected result is that during cyclone, it was to be increased. So we are getting like that results, like the wind speed is being increasing during the cyclone. And you could see one of the major results that in post-monsoon, we are getting a decrease in the case of wind speed after 5 days. And also in monsoon, we could see a decrease in the wind speed before 5 days. And in the case of ABLH, which means atmospheric boundary layer height, we could see that as expected, we are getting a decrease in the case of post-monsoon season. But in the case of monsoon, you could see that the ABLH is increasing, or the tropical cyclone is triggering an increase in the case of ABLH. If ABLH increases, which means that the chances for occurrence of cyclogenesis is less. So next, I am going to conclusion as the time is so limited. So from track analysis, we could find that the most number of tropical cyclones are occurring post-monsoon, and least is in the southwest monsoon season. And all the fluxes and the other boundary layer parameters that I have examined are showing seasonal as well as daily variations too. And it is also changing spatially in association with the passage of tropical cyclone. So next segment is acknowledgement. So I am expressing my gratitude to my gate supervisors of my project doing institution, that is Indian Institute of Tropical Meteorology, Pune, and Sri Krishna College, Guruvayur, and also expressing my thanks to Osicon and everyone for giving me a chance to present here. Thank you.
Nice presentation, Arjun. So, ma'am, you want to add something?
Thank you, sir.
Dr. Arjun, what was the source of your data?
Now, my tropical cyclones have been taken from Joint Typhoon Warning Center, and wind speed, LHF, SHF has been taken from Tropflex. Then rainfall has been taken from Aphrodite, 0.50 resolution. Then OLR has been taken from CDR data of NCEI, NOAA, and PBLH has been taken from Asia Pacific Data Research, MERA 2 B5.12.14.
All right. I just wanted to know the source of the data. Fine, thank you.
Thank you, Ms.
So thank you. Thank you, Arjun. We will go to the next presenter. It is Rose Santosh. Hope she is available.
Yes, ma'am.
Okay.
Can you hear me?
So, yeah, you are audible, and Rose will be presenting on the title Assessment of Nutrient Bioavailability and Trophic Status of Bepur Estuary, Southwest India. Rose, actually, you can upload your slides and put on the video also.
Is it visible now?
Yes. You can put it in the slide show option.
Yes. Is it visible now?
Yes. You can continue.
Okay. Good morning. I'm Rose Santosh, working as a project fellow at Center for Water Resource Development and Management, Calicut, Kerala. I'm here to present the initial findings of my project, Assessment of Nutrient Bioavailability and Trophic Status of Bepur Estuary, Southwest India. Bepur Estuary is a tropical shallow estuary that runs to the Arabian Sea in a northwesterly direction. It is located at Kozhikode district of Kerala, southwest coast of India. It had a history of severe industrial pollution from Rayon's factory. The toxic heavy metals were let into the system through Chalia River. Kavanakal Regulator Cum Bridge, constructed in 2000 to prevent the salinity intrusion, has slowed down the river and obstructed the seasonal washing of the pollutants downstream to the sea. After Kavanakal Regulator came into existence, biodiversity has been severely affected. The recent studies found that the estuary is ecologically fragile and hypoxic, warranting a detailed investigation on the health of the estuarine environment. The methodology followed was we collected surface and bottom water samples and sediments from 10 stations in the estuary, starting from Bepur mouth till Kavanakal Regulator Cum Bridge during December 2020 and February 2021, representing post and pre-monsoon season. Water samples were analyzed following Grasshoff et al. 1983, and trophic status was evaluated. And from phosphorus percentage was calculated. Not 48 ppt, 231 ppt. In the surface and bottom suggests that there is stratification in the lower reaches and it diminished in the upper stream, showing well-mixed condition in post-monsoon season. Scatter diagrams were plotted for all parameters with salinity. All dissolved major ions showed highly significant correlation, increasing with increasing salinity. It shows that total influx is the main source of dissolved ions in the aquatic system. Unlike the major elements, dissolved nutrients except silicate did not show any significant correlation with salinity, indicating their local inputs. A negative correlation of silicate with salinity indicates its major origin via land weathering. Total dissolved phosphorus varied from 1.41 microgram per liter to 148.36 microgram per liter, in which 30 to 95% was dissolved inorganic phosphorus. Total dissolved inorganic nitrogen varied from 30 microgram per liter to 108 microgram per liter, which is not a significant portion of total nitrogen. The NP ratio is below Redfield ratio, indicating that nitrogen is the limiting nutrient and phosphorus is rich in the aquatic ecosystem. Trix values calculated were near to 4, indicating low eutrophication risk. Surface sediments of these shallow transitional coastal systems are highly sensitive and could play a major role in aquatic production, whilst measurement of standing stocks gives a snapshot of the total nutrients stored in the sediments at a given time. It is the speciation of these stocks and the residence times within the various pools that controls the sedimentary storage capacity and exchange rates with the water column. Here, total sedimentary phosphorus range from 76.79 to 736.53 microgram per gram during post-monsoon, and from 96.80 to 733.62 microgram per gram during pre-monsoon, and showed significant correlation with the granulometry. It was higher near the mouth regions, and freshwater dominated regions showed comparatively lower concentration. The bioavailable fractions range from 16.52 to 40.57% of total phosphorus during pre-monsoon season and was independent of texture. It was found higher generally in the mouth region. The inorganic phosphorus fractions, iron-bound inorganic phosphorus and calcium-bound inorganic phosphorus, was found in very low concentrations. Among organic fractions, acid-soluble organic phosphorus was one of the major fractions, contributing significantly to the bioavailable fractions. Alkali-soluble organic phosphorus was one of the major fractions in saline-dominated zones of estuary. Residual organic phosphorus was one of the major abundant organic fractions. The significant percentage of bioavailable fractions in the total sediment pool of phosphorus indicate that there is a possibility of active buffering of phosphorus, which could be the reason for the enrichment of phosphorus in the estuary. So coming to the conclusions, the DIN-DIP ratio during the study varied between 0.27 and 8.29 and was well below the Redfield ratio. This clearly indicates that nitrogen is the limiting nutrient in vapor estuary and phosphorus was found to be enriched in the aquatic system. The bioavailable fractions range from 16.52 to 40.57 per 0.51 to 49.57% of total phosphorus during pre-monsoon season. It is noticed that the bioavailable fractions in the sediments actually include pre-monsoon aquatic systems. Sediments play a major role in the aquatic productivity by acting as a sink as well as a source of organic matter and nutrients. Because of the ability of phosphorus to accumulate in aquatic sediments, it acts as the internal source for the upper water column for a longer period through active buffering. This work will give better insight to the nutrient biogeochemistry of the estuary for a sustainable management of the aquatic system. Analyzing various phosphorus fractions in estuarine sediments are hence indispensable for the sustainable management of coastal ecosystem. Proper sediment quality guidelines considering the bioavailable stock of phosphorus should be an essential criteria for monitoring programs. Thank you.
Thank you, Dr. Rose. It was a good presentation, and you have made a good analysis of the sample which you collected in your study vision. My only question is that when you are trying to correlate pH with salinity or salinity with any other parameters, just try to put the what is the significance of that R square, how significant it is, because in some cases you have a very low R square. Okay. So if you put a statistical test for that, that will give a better, appreciation of the result. So that is just my suggestion. It's fine.
Okay.
Yeah.
Okay. Thank you.
Thank you.
Okay. Thank you, Rose. So the next presenter is Prerana Prakashit. Prerana is available?
Yes, ma'am.
Okay. So Prerana will be presenting on dinoflagellate cyst distribution along the Kawa coast, a HAP perspective. Prerana, actually you have 5 minutes. You can upload your presentation and put on your video, please.
Yes. Am I able to everyone?
Yes, you can continue.
So, good afternoon, everyone. My study is on dinoflagellate cyst distribution along the Karwar coast, a HAP perspective. So, what are dinoflagellates actually? So, dinoflagellates are one-celled aquatic organisms which are present in both marine as well as freshwater habitat. So dinoflagellates are considered to constitute approximately 75 to 80% of the bloom-forming species. They form cysts as a part of their life cycle. So they remain dormant for hundreds of years in the sediment. They germinate when the conditions are favorable, and that's why they are called. They are seed bank of potential harmful algal blooms. So this is the study area of Karwar, which shows that sample has been collected from 4 different stations: Sunkeri, Majali, Paithkol, and Devgar Island. Samples were processed for dinoflagellate cyst with the help of the protocol by Matsuoka et al. And with some modifications. So 5 grams of dry sediment sample is taken and washed repeatedly with distilled water. Sample is sonicated for 30 seconds. Sieve the sample for 120 micron mesh and 20 micron mesh. Samples are then centrifuged and treated with HCl, kept it for 12 hours. So the treated sample again washed and treated with cold HF for 48 hours. So washed samples again sonicated and sieved through 20 micron mesh. Residue is collected and formalin is added to avoid any fungal growth. So let's move on to result section. So these are the total 15 dinoflagellate cysts were recorded over 4 stations analyzed, and highest abundance found in Sunkeri station and lowest found in Devgar Island. That may be because Sunkeri is an estuarine region and the sediment texture is clay, whereas Devgar Island, the sediment texture is sandy granites. And Gynolax spinifera is the dinoflagellate cyst, which exhibited diverse distribution and predominated in almost all of the stations. So out of 15 dinoflagellate cysts, 3 of them, which is highlighted, 3 of them are cap-forming dinoflagellate cysts. So among these identified cysts, it is evident that there are 3 species of cysts which belongs to cap-forming dinoflagellates. They are Gynolax spinifera, Protoseraceum reticulatum, and Pyrodinium bahamus. They can trigger bloom provided with certain environmental conditions like high nutrition, increased sunlight, intense sunlight, high temperature, salinity, etc. So what we can conclude from this study is 15 dinoflagellate cysts were recorded from 5 families for the first time. And among these, 3 of them are potent harmful algal bloom forming species. The outbreak in the form of bloom has not been reported from the study area. And this is preliminary study. Much more study needs to be takes place to understand the scenario. And since Karwar Coast witnessed Noctiluca bloom frequently, that area is now prone to that area is now cause of concern for other harmful algal blooms as well. And considering the importance of Karwar in oceanic trade and as an emerging coastal tourism center, it is of utmost importance to understand bloom dynamics at play in the coastal waters of Karwar. Thank you so much, everyone.
Okay, thank you, Prerana. One quick question.
Yes. Yes, ma'am.
Dr. Smita,
hello.
audible?
Yeah, hello.
Yeah, yes.
Am I audible now?
Yeah,
yes.
now it is fine. Yes.
Should I need to repeat the question?
Yes, ma'am. I couldn't hear you.
Okay, okay. So what would be the mechanism, the cyst again back to phytoplankton formation?
Yeah. Mechanism.
Yeah.
So it's just the thing, ma'am, when the cyst forms, it settles down in the sediment. And whenever it gets the favorable condition, like for example, if for one cyst, if the high temperature is enough to bloom again, to start a new cycle, new life cycle, if that temperature is enough, then it will start. There is no mechanism as such.
So you mean to say the temperature is the major factor controlling the
Not
shift?
It's just an example. There are so many factors. Yeah, there are so many factors which can trigger the bloom. I'm just giving you the example. If temperature, we can take it for consideration. If that bloom, if that cyst got the exact temperature, then it blooms.
And is these 3 blooms are recurring, or is it?
That's what I have found. The 3 species, what I have found, the outbreak is not has been reported from the study area. It's the cyst I found.
Okay.
Yes.
Okay. Thank you.
Yeah,
Good study.
thank you.
Rishmi madam.
Yeah, just quick comment. Dr. Prerna, nice work. Okay, I have just one question to ask you: whether
Yes.
you can detect these dinoflagellates from satellite data? Is it
Yes,
possible?
ma'am. Yes, ma'am. Yes, ma'am. There is Noctiluca blooms and Trichodesmium blooms. All these dinoflagellate blooms, you can track from satellite.
All right. So you can make use of that data
Yes.
also.
Yes. Yes, ma'am.
Yeah.
Yes. Yes.
All right. Thank
you.
you.
Thank you, sir.
Okay. Thank you, Prerna.
Yes.
So the next presenter is Abdul Aziz. Hope Abdul is available.
Yes, yes.
Okay.
Am I audible?
So, yes, yes. So you can upload your presentation, and it's 5 minutes. Please remember. And the title for Abdul Aziz's presentation is "Sound Speed Variation in the Coastal Waters of Kochi and Signature of Subsurface Maxima." Okay, Abdul Aziz, you can proceed.
Can you see my slides?
Yes, visible.
Okay, very good morning to all. Myself, Abdul Aziz, research scholar from CSIR National Institute of Oceanography. Thank you for giving me an opportunity to present this topic. My presentation is on sound speed variation in the coastal waters of Kochi and signature of subsurface maxima. And this work is a part of project work carried out at CSIR NA Kochi, and this one is sponsored by Naval Research Board, Delhi. And I will give an introduction about sound speed in seawater. Sound is a form of mechanical energy that can travel long distance through water, particularly this low frequency waves. So average speed of sound in seawater is 5 times faster than air. So the speed of sound in water increases with temperature, salinity, and pressure. So 1 degree Celsius of temperature can increase the sound speed up to 4 meters per second, and 1 psi salinity can increase 1.4 meters per second, and depth 1 kilometer is approximately 17 meters per second. Sound speed can increase. So according to some particular combination of sound speed, salinity, and temperature, this sometimes the ocean forms the sound channels. That is for underwater communication, for naval applications and all. So like so far a channel that you can see here in so far channel, and this is the temperature, salinity, and the pressure of vertical profile of ocean. So my objective is describing the variation sound speed and significant along Cochin coastal water using in situ measurements, and also sound speed computation using thermodynamic equation of seawater, and what is the main control parameter that determines the sound speed relative to temperature and salinity changes. So my why I choose this Cochin estuary and coastal water is Cochin estuary is particularly it have 7 rivers that are giving the river discharge to the coastal waters, making the coastal areas low saline patch, and several studies show that the upwelling along the Cochin coastal waters during the monsoon season, that will also create the low temperature in the water column. You can see the river discharge during 2018 here, and you can see 2018 is very famous for everyone, because the flood hit to the state of Kerala, and Periyar River almost more than 6,000 meter cube per second, and this is the particular reason why I choose this Cochin estuary and coastal water. So coming to the materials and methods, in 2018 we had a monthly survey from February to October for the stations S2, S3, S4, and S5, and also a time series at the station S1. and we calculate the sound speed using TEOS 10 thermodynamic equation of seawater. And also finally, we made an ANOVA test for the significance of sound speed. So we found that this sound speed is significantly varying with respect to season, and also we have a relation to temperature, salinity, and pressure is negligible because it's a shallow region, Cochin coastal water. So I am going to the research like the major findings of this result is the formation of subsurface maxima during the monsoon season. So during the starting stage of upwelling during June, there is a low temperature in the bottom waters, and because of the high river influx from the major 7 rivers, there is a low salinity in the subsurface water. So in between, there is no significant variation of this temperature and salinity. So in between the subsurface maximum sound speed forms. So because of low salinity, low sound speed in the surface waters, and the low temperature, low sound speed in the bottom water, in between the subsurface maxima of sound speed form. This is our major findings in this study. And this correlation between what is the main control parameter that determines the sound speed means the result shows temperature and salinity have equal correlation towards the sound speed with the 0.6 and during pre-monsoon temperature is mainly controls the sound speed, and time series measurements at the Cochin Inlet in the station S1 shows the Cochin estuary is mainly the sound speed in Cochin estuary is mainly controlled by salinity. So coming to the conclusions, in the Cochin coastal waters, the salinity is varying from 0 to 35 PSU and temperature 24 to 32 degrees Celsius. And sound speed is varying from 1,500 to 1,549 meters per second. And the main result is the formation of subsurface maxima of 1,540 meters per second during the starting stage of upwelling, that is in June. So next thing is we can some numerical modeling experiments can give a better idea about the variation of sound speed along the Cochin coastal waters. This is what we are doing right now in the CSR and Kochi. And thank you all.
Thank you, Dr. Aziz. It was a good presentation. Maybe you can extend your study with more and more observations, so so that you can come up with a very the statistical, concrete results as far as the sound speed maxima is concerned. Yeah.
Actually, ma'am, this paper last month this paper is published in Ocean Dynamics Journal.
Okay, very nice, very good.
Thank you, ma'am.
Congratulations, thank you.
Okay. Thank you, Abdul Aziz. It was a nice presentation. Madam, now we will call for the next presenter.
Yeah, please go ahead.
Yeah, okay. I think MK Roxy is not available. So shall we? Yeah. Shall we go back to Vasudevan? What about Bajish and Madam?
1 second. There is some typo in this, I think. Is the name Unnikrishnan?
Roxy and Unnikrishnan, they were the authors.
Okay.
But both of them are not available, it seems. Unnikrishnan is Dr. Unnikrishnan from NIO. Okay. I think we will go back to Vasudevan Shankar. He is ready now. Is it okay?
All right.
Okay. Yes. Okay, so Vasudevan is ready. Actually, he is raising hand. So Vasudevan is presenting on wave transformation and attenuation along the central Kerala coast of India using Mike 21 SW model. Vasudevan, you can upload your presentation, and your time is 5 minutes. Please proceed. Please unmute yourself. Vasudevan?
Your mic is mute.
Hello, ma'am.
Okay. Yeah, you can present now.
Yeah, ma'am. Yeah, ma'am. Actually, I'm not able to connect internet through. So now I'm just connected through mobile phone only. So can you please next session means next presentation, ma'am?
Okay.
Yeah, sorry, ma'am. Sorry for inconvenience.
Okay. Bajish, so we will go for Anupama Sahu, right?
Yes.
Okay. Hope Anupama is ready. Anupama Sahu.
Yes, madam.
Yeah, you are ready, no?
Yes, sir. Yes, madam.
Okay. So please upload your presentation. And Anupama Sahu, presentation title is Mesoscale circulation feature on the northwestern Bay of Bengal using HF radar's observation.
Yes, sir. Yes, sir.
Please upload your presentation.
Okay, ma'am.
And put on your video, please.
Okay, ma'am.
Okay.
Ma'am.
Yes.
Is it visible?
You can put it in slideshow. It's
Yes,
visible.
ma'am.
Yeah.
Yes.
Okay. Very good. Fine.
So good afternoon, all of you. I am Anupama Sahu, MSc student of IIT Bhubaneswar. So I will be presenting on mesoscale circulation features on northwestern Bay of Bengal using HF radar observation. So, what is HF radar observation? It is the part of Indian coastal ocean radar network called Icon. There are five HF radar five pair of stations, that is Odisha, Andhra Pradesh, Tamil Nadu, Andaman Island. This is all maintained by NIOT. This is basically maintained by NIOT. So my objective is in this work is to present the mesoscale circulation feature during 2015. There are two radar stations in Odisha, that is Puri and Gopalpur. They provide hourly data set and spatial resolution is 6 kilometers. As it is very fine scale, we can study the oceanic circulation features, which is less than 100 kilometers and within a month time scale. So that's why we are called as a mesoscale circulation feature. So if you look at the circulation, at the circulation, it can almost give the current observation within 200 kilometers. So now in January, a strong current is being observed. We can see they move towards southward. And in February, this current vanishes and transition are observed. In March, the current changes to northward, and in April it is very strong, and in May it is go little bit weaken, and anticyclonic eddy stay for a week. As we see in July, we can see the current is little bit weak. The western boundary current, which is flow towards north, vanishes, and there is some eddy type structure. Eddy type structure is prevailing. In August, is another cyclonic eddy being observed near Puri coast. In September, the current feature almost similar, stay almost for a month. again in October, the current changes its direction. We can see the current now southward, but it's very weak. Whatever we see found in March and April. So the conclusion is that the HF radar can detect the current and also the speed. In springtime, it can go to 1.5 meter per second in northward direction and 0.5 meters per second in southward direction during post monsoon side. So we can detect the coastal areas, which is the order of few tens of kilometers, and stay for a few days to few weeks. So study represent the uniqueness of HF radar observation and mesoscale circulation feature in Indian Ocean. Thank you. All of you. Thank you, ma'am.
Thank you, Dr. Anupma. It was a good presentation from the utilization point of HF radar data. However, my only suggestion is that because these are very small scale ADs which you are talking about, so it is better to mention some mesoscale ADs, because normally the mesoscale ADs are of bigger dimensions. So just a small correction to that. Maybe you can take care of that in the future.
Okay, ma'am.
All right. Thank you.
Thank you, ma'am. Thank you.
Okay, thank you, Anupama. So we will go to the next presentation, Vishnu Narayanan Nambudiri. Hope Vishnu is available. Okay, Vishnu, you can upload your presentation. And Vishnu is presenting on physical settings and biochemical response of oceanic front along the coastal waters of Mangalore, west coast of India.
Madam, my slide is visible?
Yes. Yes, you can proceed.
Good afternoon all. Myself Vishnu Narayanan, working as project assistant in CMLRE. The title of my work is Physical Settings and Biogeochemical Response of Oceanic Front along the coastal waters of Mangalore, west coast of India. We know that an oceanic front is a narrow zone of enhanced horizontal gradients of physical, chemical, and biological properties, that is temperature, salinity, density, DO, and nutrients. This work is based on an oceanic front observed along the coastal region of Mangalore and its formation and its biological response. The observation was carried on board ORV Sagar Kanya during August-September 2018. We know that 2018 was a year of intense flood and rainfall. And the data sets used for the study are in situ data using the CTD data. Nutrients and pigment data are also considered for understanding of the biogeochemical changes associated with the fronts. Apart from this, satellite data sets of basket winds are also considered, and rainfall and runoff data is also considered. The map shows the study region and the frontal stations. Now coming into the observations and hydrography, when we see the near coastal regions, we can see that isotherms are shallowing in the near coastal stations, that is T402, which shows that there is active signals of upwelling. And compared to the offshore stations, when we see the offshore stations, there is relatively warmer waters. And same when we look at the salinity and density figures in the near shore region, near coastal station, we can see the due to the upwelling, the salinity is relatively higher. But when we see the T403 and T404, we can see the salinity is relatively very low, that is like nearly 28 PSU. Similar feature is observed in the density figure also. And you can see that a lot of chlorophyll and production is seen in the near coastal region. So this is the region. T403 and T404 represents our frontal station. And coming into the formation, why this front was formed in the near coastal region. We know that during the August month or southwest monsoon, there is active upwelling in the southeastern Arabian Sea. And at the same time, in the coastal region, we can observe a lot of runoff in the southwest monsoon. And the variabilities in this upwelling and the runoff, controlling the upwelling and the wind can be the major formation mechanism for the frontal observation. We know that the alongshore winds are dominant in controlling the upwelling along the southeastern Arabian Sea, and this alongshore component of wind can drag the coastal waters towards the offshore because of the mass Ekman transport. Our sampling was conducted during August 22nd, but when we see 1 week before our observation, there was intense rainfall and runoff, and also strong alongshore component of wind. And this alongshore component of wind has dragged the coastal runoff water to the offshore station, and it has led to the formation of the frontal system what we have observed in the T403 and T404. But coming into the observation period in the near shore area, near coastal station, we have observed active upwelling also. So this separation between the active upwelling zone and the freshwater trapping led to the formation of the frontal system. And when we analyze the biogeochemical response of these oceanic fronts by analyzing the nutrients and pigment data, we have seen a lot of significant variation from the frontal zone and non-frontal zone in the case of inorganic nutrients and pigments. The formation of front influence the nutrients and primary production of the area significantly. Spatial distribution of nutrients and chlorophyll A across the frontal and non-frontal regions showed enrichment of both in the frontal zone. An increase in silicate, which shows the freshwater trapping, is seen in the frontal zone, and which led to the surge in diatom species identified from the increase in fucosanthin pigment. Previous studies also have shown phytoplankton blooms to be closely associated with such kind of oceanic fronts. And we have observed many kinds of pollutants, plastic debris, and foam-like particles in the frontal system. This can significantly affect the biota and biogeochemistry, and also it can affect the higher trophic levels too. So such kind of frontal observation, like salinity front or upwelling front in the near coastal region, should be studied in a much broader way to understand, for a better understanding of our coastal system. Thank you.
Dr. Vishnu, I must compliment your work. Very, very nice work, very useful. Okay.
Thank you,
good amount of analysis also you have done with your sample data sets. Actually, and this is an extremely useful work from the point of view of coupled physical biological process understanding also. So, but I have one question. You have used this ASCAT scatometer data for your analysis along the frontal, to understand the frontal dynamics.
Yes,
any reason why you did not use the OSCAT data, which is ISRO's data? Actually, OSCAT will give you a much wider swath. That is the reason why I am asking you.
Oh, okay, madam. I think this is 25 kilometer. I have also considered AWS datasets also from our in-situ observation. We have AWS datasets also.
No, but AWS will not give you across the front. It will just give you at one location. So what I'm saying is that ISRO's scatometer, and you have done it for the 2018. So OSCAT data was there, and it has a very wide swath. So maybe you can, in future work, you can try to use that, but because ASCAT is a much narrower swath. So,
okay, madam. I'll consider that.
All right. Thank you.
Thank you, madam. Thank you.
Thank you.
Okay, thank you, Vishnu. It was a very good presentation. So we will go to the next presenter, Naveen Chandra. Naveen Chandra is available. Yeah. So Naveen's presentation is titled Characteristics of Mesoscale Eddies in the Bay of Bengal using a numerical model. Naveen, you can upload your presentation and put your video on.
Yes, ma'am. I think I have some. No. Okay. Is my screen visible?
Yes, it is visible. You can put it in slideshow.
Okay, ma'am. Yeah, good morning, everyone. I am Naveen Chandra, currently working under the guidance of Professor Vimles Pant at Center for Atmospheric Sciences, IIT Delhi. So my major research area is the major scale eddies in the Bay of Bengal. So what are the eddies? Eddies are the circular currents that are pinched off from the main oceanic current. At any time, 20 to 25% oceans are covered with the eddies. So it is very important to study the eddies and its related phenomena. So for the current study, I have used ROMs as my numerical model. The primary reason for
Naveen, your slide is not moving. So maybe you can reshare it again.
Okay, let me.
Just reshare it again, and maybe then you can.
Wait. I've stopped reshare. Is it visible now? Hello?
Yes, it is. Okay.
Yes. Carry on.
So for the current study, I have used ROMs as my numerical tool. And the primary reason for selecting ROMs for the current study is the sigma system for the vertical coordinate, which takes the follow the train of the domain and include the mathematical geometry, which is very important for this numerical simulation of oceanic eddies. My horizontal resolution is 1/18 degree and vertical levels are 50 sigma levels. For the initial condition, I have taken World Ocean Atlas 13 and lateral boundary condition from monthly climatology of SODA 3 data and atmospheric forces from trough flux and era and trim. So I have used two different methods simultaneously to detect the eddies. First one is geometrical method. In this method, local minima and maxima of sea surface height is detected and the corresponding largest closed loop is also detected as eddy boundary. In dynamical method, we calculate a Okubo VS parameter. It tells us whether the particular flow is dominated by the strain or the vorticity. If a particular flow is dominated by a vorticity, then it is termed as eddy. This is the formula of Okubo VS parameter. It should the first two terms are strain terms and the last term is the vorticity terms. If value of W is less than 0, then it is termed as eddy. Otherwise, the flow is due to the local strain. And for the tracking of eddies, whether the identified eddies at two different time steps are the same or the two different eddies. So to check this, we use a method described by Penman et al. 2005. Where a non-dimensional space property called Euclidean distance is calculated, which should be minimum. And after calculating Euclidean distance, we calculate the speed of the eddy. And for that, if the speed is more than 0.3 meter per second, then the particular eddies are two different eddies. Otherwise, it is the same eddy. The current plot shows the maximum radius of eddy attained during their entire lifespan. So this plot shows that the largest eddy formation takes place near the Visakhapatnam coast in the mid of April and have a radius of 200 kilometers. The smallest eddy formation takes place near the Paradip coast, which is also the mouth of Mahanadi River, and its radius is 8.6 kilometers. In the northern Bay of Bengal near the coast, formation of large number of small eddies takes place, and the reason for the formation of these eddies are the freshwater discharge from the rivers, and as the freshwater discharge just creates the oceanic highly turbulent, and this favors the formation of eddies. The current diagram is showing the track of the eddies. The dot points are the generation point of the eddies, and the trails shows that the track of the eddies they follow in their lifespan. the formation of eddies takes place in the entire Bay of Bengal, with majority formation takes place in the EICC region. The southern Bay of Bengal is mainly dominated by the anticyclonic eddy, which covers the longest distance from eastern Bay of Bengal to the western Bay of Bengal. In the month of January-February, EICC starts reversing its direction from equatorward to poleward. During this period, both cyclonic and anticyclonic eddies forms by splitting off from the main EICC current. From March to September, EICC starts reversing its direction from equatorward to poleward. During this period, both cyclonic and anticyclonic eddies forms. During August to September, near the Visakhapatnam coast, we can see the large number of formation of these hot core eddies, and this formation mainly takes place due to interaction of North Equatorial Current and East India Coastal Current. During March to April, North Equatorial Current starts reversing its direction from westward to eastward, and formation of low strength cold core eddies takes place. From July to September, while NEC moves, North Equatorial Current moves towards east, large anticyclonic eddies forms by splitting off from North Equatorial Current. And in this region, the topographical features also favors the formation of eddies. These anticyclonic eddies forms are traveled the largest distance in the Bay of Bengal from eastern part to the western part. The river discharge during post-monsoon period and early winter in the Bay of Bengal northern tip is also formation of large number of small eddies, and these are mainly formed due to the river discharge. The current diagram shows the contribution of eddies in the surface kinetic energy of Bay of Bengal. The total contribution of eddies kinetic energy from a minimum of goes to 7% to the maximum of 19%. And for anticyclonic, it is minimum in 2% in the month of March, and highest is 11% in the month of May. And for cyclonic eddy, it is minimum 1.6% in the month of May, and highest is goes up to 11% in the month of November. During January to March, East India Coastal Current as well as North Equatorial Currents are weaker, which results in less turbulent ocean. This lowers the contribution of eddies in the kinetic energy. From March to April, southwest monsoon starts and achieve its peak in July.
Naveen,
yes.
Can you conclude? Almost time.
Yeah, just 2 more points. And during this period, two gyre system forms in the Bay of Bengal, which contributes the highest high kinetic energy in the Bay of Bengal. In the post-monsoon season, the freshwater discharge from river make the coastal current more turbulent and generates a large number of eddies, which also results in the higher kinetic energy contribution. That's all from my side.
Dr. Naveen, I have one question for you.
Yes, ma'am.
Yes, actually you have used Ron's model, and from this model simulated sea surface height using those two methods of Dubovez and Shelton method, you have calculated the eddy census. My
Yes,
question is, have you validated your model sea surface height?
Yes, ma'am, I have validated, but due to time constraint, I have not.
No, validated with what?
With, yeah, 1 minute.
Then you can just tell.
With NIOA data, ma'am, North Indian Ocean Atlas data. And with
data? What is this data?
With temperature and salinity, I have validated. You can see right now.
No. 1 minute. You are using model sea surface height for eddies.
Not, ma'am. I have not validated sea surface height. I have validated.
Actually, yeah. So I have a very,
salinity.
okay. So take my suggestion. you have to validate first your model sea surface height, because sea surface height data you are using for, detecting the eddies and trying to understand the life cycle of the eddies. Okay.
Yes, ma'am.
So first you try to validate your model sea surface height. That will help you in having a confidence in your eddy statistics. Okay.
Yes, yes, ma'am.
Okay. All right. Thank you.
Thank you, ma'am.
Okay, thank you, Naveen Chandra. So we'll move on to the next presenter, Adira K. Hope she is ready. Adira?
Yes, ma'am.
Yeah, you can upload your presentation. And Adira is presenting on observations of currents in the Sri Lanka domain using in situ satellite and reanalyzed data.
Can you see my slide?
Yeah. Yes, you can proceed.
Okay, ma'am. Good morning to all. I'm Adria K, pursuing my master's degree at Kerala University of Fisheries and Ocean Studies. This study is a part of my MSc dissertation work, and my topic is on the observations of currents in Sri Lankan Dome using in situ satellite and the reanalyzed data. And coming to the background of this study is carried out during the southwest monsoon season, and this picture depicts the surface current circulation around the North Indian Ocean during the summer monsoon season. Here, the West India coastal current, which moves southward and joins with the summer monsoon current, eastward flowing summer monsoon current, and the interaction between these currents and the island of Sri Lanka, and also the presence of the wind stress curl around this region, which creates a cyclonic eddy around the eastern part of the Sri Lanka. This cyclonic eddy, which is the so-called Sri Lankan Dome, and this matures at the month of July and August, and which forms at the month of May. And this region, the Sri Lankan Dome, is characterized by a low sea level anomaly and the geostrophic winds around this region, which reveals the cyclonic rotation of currents. Then the main objective of this study is in present study, we examined and analyzed the different types of data sets, such as X-band marine radar surface current data and the Oscar data product, and the surface currents from the Meteorological and Oceanographic Data Archival Center, all along the SLD region. Then the comparison of the different types of data sets are carried out here. And this is the first kind of surface current measurement in India using the X-band marine radar system along the Sri Lankan Dome around this region. And the in situ data is taken from an X-band marine radar system on board INS Agaduni, which having a spatial and temporal resolution of 7.5 meter and 2 second respectively, and which follows this instrument, which follows the Bragg's theory. The main output parameters are these. And coming to the resultant discussions, the surface current vectors from Oscar overlaid above the sea level anomaly for the month of July, which reveals the cyclonic eddy with a negative sea level anomaly about minus 0.1. And this reveals there is a occurrence of Sri Lankan Dome having a diameter of approximately 220 kilometer, and the maximum current speed along this region is 0.9 meter per second, which can be measured. And there is an anticyclonic eddy adjoining to this Sri Lankan Dome was also observed. The vertical profile of the horizontal current vector component around this region, which gives a thick core occupying the upper depth of 150 to 200 meter, which exhibits rotatory surface currents of approximately greater than 0.5 meter per second at the periphery of the cyclonic eddy. And at the center of the cyclonic eddy, there is a low velocities. Then the vertical velocity plot, which shows the spatial distribution of the currents and vertical currents, which is upward with a velocity of 4 meter per day, which is due to the upwelling at the core of the cyclonic eddy. Then the surface current vector plot using X-band marine radar data and the Oscar surface current data along this region, which is along the 10 degree north. The ocean currents is southward at the 84° north and northward at 86° north. This reveals a cyclonic rotation around this region, which reveals the presence of Sri Lankan dome. Then the current vectors from Oscar and X-band marine radar data, which shows a high resolution of X-band marine radar data. Then by concluding that there is a northeastward current wave observed on the eastern side of the Sri Lanka with magnitude up to 1 meter per second. And also the SLD Sri Lankan dome was observed with its center around 10° north and 85° east, having a diameter of 220 kilometers. Then the comparison of different types of data sets gives that the Oscar and X-band marine radar data showing a high correlation, a good correlation for the zonal component of currents. Then so we can use the X-band radar data to study fine scale ocean dynamics over an area of interest. Thank you.
Dr. Athira?
Yes, ma'am.
Yeah, good study. Okay.
Okay.
I have a couple of suggestions for you. I mean, you can you make use of these suggestions in your future research work. One
Okay,
is
ma'am.
this Oscar current and the Mazda current that you mentioned. I hope you know the difference between the two currents. Okay, both are actually satellite derived currents. Okay, but one is at a daily scale and another is at a 5-day scale. So
Yes.
the Mazda current is daily scale. Okay, and the Oscar current is a 5-day scale. So every 5 days you get the data. So you should be a little careful in making the interpretations using these two data sets. However, the spatial resolution is same in both the cases, 25 kilometers. Okay.
Okay.
Now my second point is, see, you are using this X-band radar data. Okay. I would assume that X-band radar data will be giving you a much better, much finer observations as compared to the satellite data.
Yes.
So you just keep these things in mind for your research, because the small scale feature that you are talking about, finer scale, you should be able to get in X-band radar data, but you will not get it in the satellite currents data. Okay.
Okay.
So these are just my suggestions for your
Okay.
further
Thank you,
research.
ma'am.
Okay.
Thank you, ma'am.
All right.
Okay.
Thank you, Athira. Thanks.
Thank you.
Okay, thank you, Adila. So we will move on to the next presenter, Vasudevan Shankar. Hope Vasudevan is ready with the connectivity. Yes. Yes, you can upload your presentation. And Vasudevan Shankar is presenting on wave transformation and attenuation along the central Kerala coast of India using Mike 21 SW model. Vasudevan, you can upload your presentation.
Smita, is he having still the problem in uploading and in connecting?
I think, yes. Vasudevan, he's not responding.
Okay, so what should we do then? Maybe you can just ask for his presentation and we will have a look at it. Is it okay?
Yes.
Or I don't know. You can ask the organizer what should be our take. I think Dr. Baji should guide us.
No, since he didn't send it like previously, he didn't send it. So maybe we don't have his PPT also.
All right.
So So maybe, yeah, we can conclude if he's not. I think he's online. So
yeah, seems to be connectivity, weak connectivity. So maybe because of that he's not.
Bajish, I talked to him.
Mm-hmm.
He's trying over his mobile.
Okay.
No connectivity with the system, it seems.
Okay, so we will wait for a few minutes. No issues. Okay.
Maybe ask him to send the copy, so that we can show the presentation and he can talk.
Right.
Just ask him to send the mail.
Okay.
Smita ma'am?
Yes.
So we are going for lunch.
Hello?
Hello.
Yeah.
I'm audible?
Yes, audible.
So we are going for lunch.
One more presentation. The presenter is having some connectivity issue. 5 minutes, please.
Okay, ma'am.
Hope it's okay. Okay. Bajish?
Yes.
He will be sending it to both of us. So please.
Yeah. Okay. Yeah.
Hello.
Yeah. Have you sent
Hello?
your presentation?
Yeah, ma'am.
Yeah.
Yeah, I sent mail, ma'am.
Okay.
Hello?
I haven't received it yet. Bajish, are you checking?
We got, ma'am.
Got?
Dr. Vasudevan, otherwise you can just brief us about your results. Smita, will that help?
Yeah, that will help actually.
I think you can just
Because
brief us about the kind of work he has done, the data set and his findings.
yeah.
I also didn't receive his mail, so maybe it will be like it will take more time. Maybe yeah, as ma'am mentioned, let him just talk without the PPT.
So Vasudevan, can you brief it? He's mute, it seems.
Smita, please call him up.
Okay.
Yeah.
Yeah, Vasudevan, we didn't get your presentation till. So you please brief your work. Okay, without the PPT slides. Okay. Hello, Vasudevan. Okay.
Hello.
Okay, continue, Vasudevan. Actually, I can say your title. It is again wave transformation and attenuation along the central Kerala coast of India using Mike 21 SW model. You please brief on your work.
Oh, yeah. Okay. Sorry for the inconvenience due to network issues. I'm not able to upload my presentations. So I just give a short introductions. What I'm going to present. Wave transformation attenuations along central coast of using central Kerala coast using micron spectral wave simulations. Here I'm taking wave data, simulated wave data, generated wave data, generated wave by wind and here I am separated from the waves. Keep using my tool spectral wave simulation model. Then I simulated. Then I simulated the model from source and I validated validated with polygon regions that
Smita, is it that I am having the problem at my end or his voice is not audible?
Yeah, now he is not audible.
Okay.
Or,
Okay, okay, Banish, thank you.
yeah.
I mean, the internet connection is weak.
Yeah, that's it.
So I think maybe we can wind up.
Right.
Yeah.
Right. Right.
So
should we do that?
yes, I think so. Yeah.
Okay, so I'll just give a few concluding remarks and then we'll wind up this session. So I'm very happy with all the presentations and which covered most of the coastal and the open ocean research. Many of the presentations used a lot of in situ, a lot of satellite data, and also some experimental setup was also talked about. And the another important aspect of this session was that I mean it covered all the areas of oceanography, like biological and physical both, and a few talks were especially very pertinent, specifically from the coastal pollution point of view and coastal threats like coastal erosion and all other aspects. So in a way, this was very fruitful and a very enriching experience for me. And I'm actually extremely thankful to the organizer and specifically to Dr. Ravichandran for giving me this opportunity. And last but not the least, I thank all the participants and my specific thanks to Dr. Smita and Dr. Bajish, with whom I enjoyed conducting this session. So thank you, Dr. Bajish, and thank you, Smita. I hope to continue our interactions in future also. Thank you.
Thank you, madam. Thank you so much. And Actually, me too feel actually it is a vast coverage of subject from coastal to ocean processes, ecosystem dynamics, and coastal protection, etc., from in situ to satellite to model. All the presentations were good, and few, as Madam mentioned, were extraordinary. And I too enjoyed the company the company of Madam and the discussions. And Bajish, actually, you were so supportive and friendly. Thank you so much to both of you and to the organizers. Of course, we are all part of OSI and the NCPR team, Ravichandran sir, and the whole team of NCPR. Thankful to all for giving such an opportunity. So, Bajish, if you have to say
Actually,
something, then you can
Madam
conclude.
already told you both already covered all what I have to say, but it was a pleasure interacting with both of you. And also, I congratulate all the participants for their excellent presentations. And thanks to the OSI team and NCPR team for conducting this conference. And I think we should wind up. We are, I think, over time now.
Okay. So, but
Okay.
we have to meet sometime, Dr. Bajish, for.
Yeah. I will. That we'll do privately, not in this.
Yeah.
Okay.
So you can just intimate us so that we
Yeah.
can.
Okay. Yeah.
Okay. Thank you.
Okay.
Have a good time. Yeah. Bye.
Okay.
Thank you. Okay, Hitesh, we can wind up now.
আমি ইউটিউবটাও খুলে রেখেছি।
হ্যাঁ ওটা সেটা তুমি ওদিকে ইয়ে করো। এখানে কোথায় দেখতে হবে আমি দেখছি, এখানে বোধহয় চ্যাটে আসবে তো।
হ্যাঁ এই আস্ক এ কোশ্চেন জুমের চ্যাটে আসবে।
হ্যাঁ জুমের চ্যাটে, কারেক্ট। ওকে, hello Dr. Silan, can you hear me?
Can you hear me?
Yes I can you hear me?
Yeah I can see you also.
Yeah okay. Saurav,
Yes sir.
can you hear me?
Yeah.
Okay.
Good afternoon Silan sir.
Thank you.
Yes.
Sir, actually my video is dead.
It's not working or what?
I don't know. Oh, maybe. I was seeing my video.
Yeah, let me change the name of it's actually my daughter's laptop.
I can no you are there. I can.
No, my name is actually written Sanbi Chakravarti.
Yeah, I was also I was also thinking that Kunal's name has changed.
No, actually this is my daughter's laptop, so I just make use of that. Okay, so Saurav, we are fine. I think we are able to actually hear each other, able to see each other, and I think 2 participants have already joined. Oh no, only one.
Let's wait for some time. 5 minutes to go.
Yeah, we have time. So in the meantime, we can ask them to check.
I think
check loading the PPT and see whether if they have any difficulty, we can help them now.
Yes, correct. So Mr. Hitesh, can you just share your PPT? We just wanted to check whether it's working fine. Yeah, Hitesh, are you with us? Can you hear us? I think he is not nearby. So let's wait for another 2-3 minutes, then probably we will make an attempt. Yeah, I think we can see you now.
Yeah. Actually, I opened another window.
Okay.
That is what was stopping this. Okay. The Zoom has a problem actually. Zoom, I think I don't know which direction it sees. Zoom's, you can see me, right?
Yes, we can.
Oh, okay. Maybe I cannot see that. I cannot see me properly. Okay, that's okay.
We can see you.
Oh, okay.
It's clear.
I can see you. So what we will ask them to present for 12 minutes and 3 minutes. Leave 3 minutes for.
Yeah, question answers.
And so you will give some warning.
I am going to check the timings and all. Anyway, myself and Saurabh both we will check. So what I will do, I will introduce you first, and then I will hand over the forum to you so that you can basically call one after another the participants, and we will basically see the 12 minutes, and then we'll give a alarm like another 2 minutes left and all. That we will look.
So 10 minutes plus 2 minutes or?
No, 12 plus 3. So 12 minutes they will present, 3 minutes for the question answers.
Yeah, but it is better to tell them that at 10 minutes, that 2 minutes left, so that,
Okay.
They'll take another 2 minutes to finish it.
Fine.
2 or 3 minutes. I mean, we can be a little flexible.
Yeah, that's
2 or 3 minutes. Yeah. So 10 minutes we can just give them a warning.
Warning, yeah. Fine. 10 minutes we will give a warning so that by 12 at least, or by another 1 minute they will be able to finish it.
Correct. So we have seven presentations here in this.
Yes. Actually, they have given 1 hour 45 minutes, exactly 15 minutes into 7.
Fine. That's okay. I think we'll. And the order is Jay Kumar, Abhijit Raj. Yeah, can you please see that?
Yeah. Jay Kumar, Abhijit Raj, Vaishnavi, Srinivas, Subroto, Mayur, Hitesh.
Correct. Fine.
This is the order.
Okay. Excellent.
Okay, so
I think I see Jay Kumar here, so we can ask him to try loading the PPT. Jay Kumar, can you please share your screen and see? Yeah, excellent. So can you go to the next slide? Next slide. Slides are not moving. Yeah. Okay. Good. Okay, so please stop sharing. Yeah, Jay Kumar can stop sharing now.
Yes.
Okay.
Then yeah, I could see.
Hitesh is there. Hitesh, are you there? Please unmute your mic. Hitesh, if you are there, please share your screen.
Another thing, if in between some of them, like they will face difficulty in sharing their slides, or there are some technical issues in like audio or video, probably we will go to the next one, and then we'll take the in the last, like after completing that we will take at the end.
Correct. And yeah, so Vaishnavi has come. So
yeah,
Vaishnavi, can you please share your screen? You know, there are options in the bottom. See, there's a green and arrow, upward looking arrow. Click there. So you can please unmute your mic. The share screen is there. Click there. Click share screen. Please unmute your mic. Can you share your screen? See, if it is not active, please click on the box. There's a box inside, right? Click that box. So take your mouse inside the box. It will then it will be activated. Yeah. Fine. So,
good afternoon, everyone. Hello.
Yeah, good afternoon.
Good afternoon.
Dr. Kunal, sir?
Yes.
We are live now.
Okay. Thank you. So I think we can start now. It's 2.
Fine. Yeah.
Okay, so let's start, I think.
Yeah.
Okay, so good afternoon, one and all. We welcome you all to this session, Mathematics in Ocean Science, in Osicon 2021. In this session, we have total 7 presentations, and I'm pleased to introduce the session chairman, Dr. C. Gansilan. So, Dr. Gansilan is working as a scientist G in the Indian Institute of Tropical Meteorology, Pune. He is the project director of short-term climate variability and prediction project. He has done his MSc in mathematics from Madhuraj Kamraj University and PhD in mathematics from IIT Kharagpur. He has contributed significantly to the field of climate impacts, ocean modeling, and Indian monsoon with nearly 30 years of experience. He has 136 of research publications and has received several awards during his research for his outstanding contribution in the field of atmospheric sciences. Dr. Gansilan has guided 15 PhD students and 30 postgraduate students. He has actively participated in several projects, and he has been a PI and co-PI of 7 such renowned in national and international projects. Those are associated with the research of the Indian Ocean and monsoon variability. So I welcome Dr. Gansilan to this session, and I request Dr. Gansilan to take over and go ahead with this session. Thank you. Can you are not audible. Can you just unmute? Yeah, please.
So good afternoon, everyone. So we welcome you all for this parallel session on the mathematics and ocean sciences. And we have 7 presentations of 15 minutes each. So out of 15 minutes, 12 minutes for presentation and 3 minutes for question answers and discussion. So I request all the speakers to limit their presentation, stop their presentation by 12 minutes. So we will give you a warning after 10 minutes, so that once the warning is given, please summarize and proceed for the discussion. The first presentation is by Jay Kumar. Yeah, Jay Kumar, he will be talking on study of mixing and biological activity in the Arabian Sea using finite size Lyapunov exponents. Jay Kumar, please.
Good afternoon to all. I am Jay Kumar from Space Application Center, Ahmedabad. Title of my paper is A Study of Mixing and Biological Activity in the Arabian Sea using Finite Size Lyapunov Exponent. Outline of this presentation are: first, I will explain numerical method used and data set, then state of the art, result and discussion, which contain 2 sections. First is validation, second is application, and then conclusion. In this work, numerical method used is finite size Lyapunov exponent. Here are the details about numerical technique. Equation 1 gives FSLE field. Here delta 0 is the predefined initial separation between difference point and its 4 neighboring particles. Delta F is the predefined final separation between difference point and neighboring particles, and tau is the time taken for achieving the desired final dispersion. Delta F corresponding to the orientation of the maximum separation rate. Coupled equation given by 2 are used for advection of fluid particles in longitude-latitude frame with geostrophic approximation. For computing FSLE fields, 3 different data sets are used. First is NAMO model data. This is a global model with a spatial resolution of 25 km and temporal resolution of 1 day. Satellite derived surface currents taken from MOSDAQ, SAC, ISRO. And third, high resolution in-house OGCM data product for surface velocity field in BOB region with a spatial resolution of 2 km and temporal resolution of 1 day. Other than these 3 data set, daily averaged chlorophyll concentration data with a spatial resolution of 4 km is taken from ocean color for application purpose. Then state of the art. Here is the state of the art. Technique of FSLE start evolving around 90s. Orel et al. And Artale et al. 1997 used it to study known asymptotic dispersion processes, which is particularly appropriate to analyze transport in closed areas. Until 2004, FSLE have been used for 2 complementary goals. First is for characterizing dispersion processes by Lacorata et al. 2001, and second for detecting and visualizing Lagrangian structures, Coho and Lagrange 2002. But these studies were limited to only in closed boundaries. So in 2004, D. Ovidio et al. First time used FSLE for detecting and visualizing Lagrangian structures in oceanic flow, as well as introduced measure of dispersion and mixing based on the Lagrangian structure detected. 2 important conclusions of their study were: stretching and contraction properties of transport in geophysical data can be studied by the forward and backward FSLE respectively, and chaotic motions are characterized by complex intersection of stretching and contracting manifolds. In 2008, Rossi et al. Applied this technique for characterizing the horizontal mixing properties in 2 eastern boundary canary and Bangula upwelling systems. They found that surface horizontal stirring and mixing vary inversely with chlorophyll standing still. Same authors in 2019 extended this study. Then Mathur et al. 2019 investigated two-dimensional advective stirring in North Bay of Bengal by using backward and forward FTLE in place of FSLE. They found that large-scale thermal fronts present in sea surface temperature field closely resemble attracting LCS. Also, thermal fronts are shown to have a strong preference to align with sufficiently strong ALCS in their neighborhood. Then in 2020, Poland Suktami used the technique of FTLE as well as FSLE to study the steering of passive tracers in Bay of Bengal on sub-seasonal time scale. They found that steering is local and does not span the entire basin. Also, steering rates are found relatively higher in the pre and post monsoonal seasons. Result and discussion part is divided into two parts. In first part, I will discuss validation, and in second part, application of the technique. In validation part, first is sensitivity analysis of FSLE strength and developed FSLE structure is performed with respect to temporal resolution of the input velocity field. FSLE fields are generated by using surface velocity field from in-house high-resolution ocean circulation model with a spatial resolution of 2 km and temporal resolution of 1 day. Objective here is to look how the FSLE field structure vary as a function of temporal resolution. For this, 5 different temporal resolution are selected, that is 1 hour, 3 hours, 6 hours, 12 hours, and 24 hours. From these plot, we can conclude that FSLE fields look similar as a function of temporal resolution from the pattern point of view. But as the temporal resolution of the data field decreases, weak FSLE field start diminishes. In large plot, that plot number 2nd and 3rd, indicates that the fine FSLE features are missing in the fields computed using low temporal resolution coarser than 12 hours, indicated by arrows. That arrows I kept here. This implies that for detecting submassive scale FSLE features, at least velocity flow field of 12 hours temporal resolution is required. Next is sensitivity analysis of FSLE strength and developed FSLE structure for varying final relative dispersion. For this exercise, initial separation is kept fixed at 5 km and final separation is chosen from 50 to 250 km with a delta increment of 50 km. These are the corresponding contour plots. From here, we can conclude that as expected, the strength of FSLE decreases as delta F is increased. With low delta F, the FSLE strength is quite high. It is around 0.1 per day. While for high delta F corresponding to 250 km, the strength of FSLE reduces to 0.05 day. As final relative dispersion increases, FSLE field start disappearing, and for relative dispersion of 250 km, it almost completely disappear in the third region, as can be seen from here. To get more insight about impact of relative dispersion, one on the strength of computed FSLE field, time evolution of area averaged FSLE field for final relative dispersion of 110 and 250 km are computed. Here, 3 regions are taken as defined previously. From here, it can be seen that area averaged FSLE strength are small for final relative dispersion of 250 km compared to 110 km, and area averaged FSLE strength have a similar pattern as a function of time for the both considered final relative dispersion. Further, to check the validity of the FSLE fields computed from surface velocity field using NAMO model data, we computed the same from satellite derived currents. Here, area averaged values of FSLE fields are plotted as a function of time. From here, we can conclude that there is not much differences in FSLE field computed from NAMO and satellite derived surface current, and observed differences can be due to different type of inaccuracy present in the 2 different data set. In application part, first activity is to identify the potential mixing zone in North Indian Ocean by using the FSLE field. First figure shows the contours of time mean of backward FSLE, and second figure shows contour of time mean of forward FSLE field for the duration of December 16 to December 2020 in North Indian Ocean. As mixing activities, it is well known fact in the literature, in the ocean are characterized by presence of FSLE in that region given by D. Ovidio 2004. So here we found 4 regions in North Indian Ocean where the FSLE magnitude is substantial. Region A shows maximum intensity of FSLE and is the region of intense upwelling that happens during the Indian summer monsoon season. Region B also show strong FSLE pattern. This region is associated with the seasonal upwelling during summer monsoon and winter time. Region C shows moderate FSLE pattern, which is associated with the winter anticyclonic circulation that form the Lakshadweep eddy. And region D is along the east coast of India, where the strong FSLE features are associated with the East India coastal current. Further, we see that whether there exists a correlation between area average mixing strength given by M plus minus and M plus inactive zones present in Arabian Sea as found by D. Ovidio in Mediterranean Sea. Same type of result was found by D. Ovidio in Mediterranean Sea. So from these 3 plot, a correlation between the considered 2 parameters is clearly visible, like in Mediterranean Sea. This is an important result which tells that forward and backward FSLE field exist simultaneously in an active ocean region due to their positive correlation. Then next, a study is made to find relationship between time evolution of area averaged backward FSLE and chlorophyll concentration during the period December 16 to December 2020. In region A, that region already I described, region A, B, C, and D, but here I am covering only first 3 regions. In region A, for complete duration, it can be seen during July to December when the mixing strength are high. Chlorophyll concentration first increases during July to August and then decreases during October to November. And these results did not show a direct negative correlation among both. In region B, the time evolution of mixing strength and chlorophyll concentration is negatively correlated during winter time, which peak in mixing strength corresponding to low chlorophyll concentration, and we expect a negative correlation. Region C to exhibit strong seasonal variation in mixing strength with maxima occurring during month of February and minima during August. There is a definite anti-correlation observation with mixing strength in this region.
Excuse me, Jaikumar, you have 2 minutes left.
Yes. The next application of technique is to study correlation between chlorophyll concentration and backward FSLE field by using monthly means of both the field. For this, 3 boxes of size 1 degree into 1 degree are selected in the Arabian Sea. Each point corresponds to monthly mean of area averaged backward FSLE and chlorophyll concentration in 2D space. And linear curve in each plot is a linear regression line. From here, we can conclude that if someone plots spatial averages of backward FSLE versus spatial averages of chlorophyll concentration over each subdomain for each month from December 16 to December 2020, a negative correlation, as we can see in these figures, between backward FSLE and chlorophyll concentration emerges for all 3 areas. The subsystem with the highest mixing activity are the poorest in chlorophyll, which we can conclude from these results. But similar results were obtained by Rosie et al. 2008-2019 in the Eastern Canary and Bangalore upwelling system at local as well as at global scale by using Fourier data. Then next is to study accumulation zone via backward.
I think Jaykumar, you're not audible. Hello.
Jaikumar, can you hear us?
I think his connection is lost.
Yeah. Yeah.
Yeah, it's fine. Jaykumar, yeah. Jaykumar, are you able to hear us?
No, I think he's not in the participant list.
Oh, okay. So he got disconnected. Yeah.
Yes, yes. Oh, he has joined again. So probably he can.
That's okay. We can have the questions. Do we have any questions from anybody?
Jaikumar, did you hear? Yeah, I think, yeah. Can you hear us?
Yes, sir.
Okay.
Actually, internet, I lost the connection.
That's okay. That's okay. Your presentation is over. That is fine.
Okay, sir.
So we can take any quick question.
Yeah,
Quick questions. Yeah. Anybody has questions to Jay Kumar?
From chat box, I don't see any questions as of now.
Okay. Jay Kumar, I have a question. See, now when you compare the FSLE versus the chlorophyll, in many regions the correlation is very poor. Do you have any comments on that? Except one region where the correlation is about -0.4 or about -0.4. The other regions the correlation is very weak. So you have any comment on that? I think again we lost Jagmar again. He may have a poor internet connection.
Yeah.
Okay, thank you, Jay Kumar. We will move on to the next presentation. The next presentation is by Abhijit Raj. He will be talking on evaluation of the best performing WaveWatch 3 model setup for the Indian Ocean.
Hi, sir.
Yeah, Abhijit Raj. Yeah, you are audible. Yeah, can you please share your screen?
Yes, sir. In a moment.
So Dr. Silan, if somebody has any questions, probably you will take at the end.
Right. Yeah. After all the presentations are over, I request all the participants to be there so that all the questions we can take up in the end.
Okay. Yeah, Vijit, you may please go ahead.
Good afternoon, all. Myself, Abhijit. I'm a JRF from
I am not able to see the presentation. You are able to see?
No, even we can't see your presentation.
Actually, you have not shared the screen.
Oh, 1 second. System is showing some problem. But
so go to share screen option.
Yes.
Click inside the box. Then
Can you see now?
It is coming up.
Not yet.
It is coming up. I think.
Yeah.
Please share.
Now we can.
Yeah. Please go ahead. So make it full screen. Presentation mode.
Is it visible now? Yes.
Yes. Please go ahead.
Okay. Good afternoon. I'm Abhijit, JRF from Incois. I'll be this opportunity to present our work, evaluation of WaveWatch 3 model setup for Indian Ocean, by which we try to find best performing setup for the Indian Ocean. The wave model act as accessible and effective ways of ocean wave forecasting and have been in operation for, say, 5 decades, providing data for various marine applications. You might be thinking, why this domain and why this study? So Indian Ocean presents a full spectrum of wind conditions like low to medium wind during this pre-monsoons, high winds during these monsoons, and unique seasonal reversal of winds in between. So these winds generate a complicated wave field consisting of sea and swells and make it a challenge for accurate forecasting. So with this study, we present an extensive validation and evaluation of various WaveWatch 3 input source terms against various observations under different conditions. So I will start with explaining the basic model setup for WaveWatch 3. We used WaveWatch 3 version 6.07 for the study, and the model was forced with 3-hourly ECMWF winds with a spatial resolution of 0.25 into 0.25 degree. And we generated different simulations using schemes ST2, ST3, ST4, and ST6, namely, with different parameterizations for the drag coefficient. So there's a flowchart I have given which represents the schemes and corresponding papers or others. And wind input is determined by wind wave interaction parameter beta and by friction velocity, which is defined by drag coefficient. So different values of beta was also used to fine-tune ST4 and ST6 schemes. And these are the validations I have made in this work. We have made in this work. So as I said, extensive validations were made with 6 deep water buoys from NAOT, that is AD06, AD07, and AD09 from the Arabian Sea, and BD08, BD9, and BD14. Sorry, BD8, BD11, and BD14 from the Bay of Bengal for a validation with the model. And the validations were made in the year 2017. And also spatial validations from that with the data from JSON 2 is also done. So with the boy data, the first validation done was wind range wise performance validation. Since model performance mainly depend on winds, and due to unique wind pattern in the ocean, a classification of this collocated data based on 3 wind regimes was done. That means the collocated data was grouped into 3 based on wind speed ranges, that is weak winds, medium winds, and strong winds, in order to understand the performance of model under these scenarios. And then we thought, what if wave model is dependent on wind? Then why don't we take a look at the forcing winds? So a comparison was made in between observed winds from the buoys and model forcing winds, 0 to 5, 5 to 10, and greater than 10. These are the 3 wind speed regimes I mentioned. And these bias RMSE correlation and scatter index was made between the measured in situ winds from the buoys and the model forcing winds from the ECNWF. And from this, we can see that there's a good correlation and better RMSE with the least scatter index between model and measured winds at this medium range winds. And during this low winds and high winds, it is not so visible. And for that, this first analysis, just because there is an errors in the forecast winds, and it has been taken care while this model estimate has been validated. So for that, we considered or repeated this whole analysis with those data points where model and observed winds bias is so small. And similarly, an analysis was made for model performance evaluation during these 3 seasons, that is pre-monsoon, monsoon, and post-monsoon seasons. And similarly, to know model forecast reliability under extreme condition, a case study of cyclone Oki was also done. And similar study was done for swell events also. And the satellite altimeter JSON gives us significant wave height data and over Indian Ocean domain. So in order to compare that and study that in detail, we divided the domain into 3 subdomains, namely NIO, TSIO, and ETSI, which I will discuss later. And okay, this represents model statistics for wave parameters, significant wave height, and mean wave period. There are 8 colored bars, which represents 8 model tuning setups we have made for this validation. And the left side represents significant wave heights, bias, RMSE, correlation, and scatter index. And the right side represents mean wave period, corresponding statistics. And if you are looking at this weak wind range regions, we can see the green one, that is ST3 scheme is showing maximum bias and high scatter index and poor correlation. One thing to look is that the total wave height is a combination of sea and swell, and results have to be assessed based on that also. Like if I am getting a high values in swells and a low value or underestimation in seas, I will be getting a good estimation here. So we did an estimation for this also. The first plot represents swell wave height and its statistics. The second one is sea wave height, similarly for period also. And I'm not explaining all these things. After this analysis, we got the best performing scheme in the weak winds to be ST2. That will be this blue colored one, followed by ST4. ST4, we made 4 tuning setups by altering the wind wave interaction parameter, and that is all represented here. And in medium range, performance of different schemes was similar, with only difference is that a decrease of bias and errors compared to what we saw in weak winds. And in overall, ST4 471F scheme presented well. That is the violet colored one. And in strong wind regimes, ST2 was showing strong bias in HS. That is the first color, light blue color one, along with a high scatter index. And if we can see, like ST4 and ST6 schemes performs well compared to ST2 and ST3 schemes. And this is consistent with the previous literature saying that ST4 scheme performs well throughout the Indian Ocean basins, and it is said in the previous literatures. But as said, forecast wind itself has errors that should be considered while deciding the best scheme. for instance, this weak wind case has a huge positive bias, and this itself could have causing this positive or this positive bias in wind, wave height estimate. So in order to check this, we consider the accurate wind forecasting case only, and performance of different schemes are highly related to accuracy of wind forcing, and it is said in the previous lectures. So in this validation, the model winds which are matching with measured winds are only considered, and this evaluation shows that one second. We can see that all the schemes are performing poorly under weak and strong wind regimes. And from this validation, we can summarize ST4 scheme, which performed well in the previous studies, also tend to underestimate under this high wind cases. We can see this here, this violet line. And ST6 FLX1, that is this one is the best performing scheme under this high wind regimes. And also ST2 performed well in weak and medium wind ranges also. Here it is having a high RMSE and low correlation. And all these analysis have been done based on this remotely located buoys across the North Indian Ocean. So in order to get a wider picture, we compared or we did a spatial validation with the satellite altimeter JSON. And as I said, the entire data was split into 3 subdomains: North Indian Ocean from up to 0 degree north, and the tropical southern Indian Ocean up to -23 degree, and beyond that extra tropical southern Indian Ocean. And these are the corresponding statistical plots for 3 locations, and the gray background indicates the mean wave height. And we can see in the ETSA location, that is extra tropical southern Indian Ocean, we have high winds observed throughout compared to other 2 basins, which might be due to the high activity of westerlies and other waves in the southern oceans. And in this also, the previous results repeats, like ST2 471F, that is the violet colored one, is performing well, or in an oral analysis, we can say that ST4 471F is the best performing scheme, followed by this ST6 scheme. And for understanding model performance under extreme event, before that, validation were made for different seasons also. For now, till now, we did the analysis based on wind speed ranges. But during this, for this analysis, we split the data into 3 seasons, and we can see the maximum wind wave height during the monsoon seasons. And in this analysis also, we can see the best performing scheme for Indian Ocean setup is ST4 471F. And for understanding the model performance under this high or extreme event,
Abhijit, you have less than 2 minutes left.
Okay, I will wind up in very quick. So this cyclone Oki was considered, and this number show we have selected Oki, and it caused around 844 deaths across India and Sri Lanka. This plot represents cyclone track, and the color represents the intensity. 8007 buoy and 8009 buoy are along the track for our study period. And this number shows the significance of identifying best model setup. And these are the significant wave height plots during these cyclone events at these 8007 and 8009 locations. The black line indicates the estimates from the buoy, and the colored dots indicates the model estimates, and the blue lines indicates buoy estimate, buoy and model wind speed. It's given the left y-axis. So in the analysis, there is one more thing. The cyclone passed through this 8007 buoy, and it stopped giving data right after itself, but 8009 gave data. So from this, we can understand that both buoys were able to pick up the cyclone. I mean, both buoys were able to pick up the storm signal very well. And ST6 FLX1, that is a red color dot, is able to recreate very well compared to other schemes, and which is consistent with the previous studies also. I mean, in high wind speed regimes, ST6 scheme performs very well. And okay, so I will wind up here. These are the inferences I'm having. During the strong winds, ST6 scheme performs very well compared to other schemes, and ST6 has a strong negative input, and it predicts the strongest energy loss. And in all other situations, the best performing scheme was offered by ST4 scheme. And in our analysis, in different wind ranges, in various scenarios, it is clear. It clearly shows that performance of parameterization schemes in low winds are not accurate, and which is independent of wind error. And all parameterization schemes have to be fine-tuned for predicting waves for the low wind regimes. And that's it. Thank you.
Thank you, Abhijit. Any questions to Abhijit?
From chat box, I can't see any questions. Saurav, anything in YouTube?
In the meantime, Saurav, I will ask a question. See, you said you have validated the model with the different the parameterization ST2 to ST6, for example.
Yes.
So now, when an operational forecasting situation arises, how do you know that you need to do the ST2 or ST6? How do you handle this issue?
So for that, we considered this many different kind of situations. Like we considered swell events, we considered spectra that I didn't explain in this. Also, we considered extreme events like cyclone, also monsoon. From all these analysis, we can take this ST4 471F setup with to be the best performing scheme for Indian Ocean. But during a heavy cyclonic event conditions like ST6 yields faster wave growth for young seas, and this scheme is best performing for cyclone conditions. Rest other conditions, ST4 scheme is good.
So you first look at the forecasted winds and then take a decision. That is what you do?
From this, I did this much analysis and find this. So in future, I might not be needing to do this, right? I can use this as a reference.
Okay. Okay. Thank you. Thank you, Abhijit. Any questions from YouTube?
No, sir, nothing is there.
Okay. Thank you. Thank you, Abhijit. Thank you.
Sir.
Thank you for the nice presentation. Yeah.
Thanks,
Can you
sir.
please stop sharing?
Yeah, I'm trying. 1 second. Okay.
Yeah.
Yes.
The next presentation by Vaishnavi. She will be talking on cubic spline polynomial as input energy spectrum for determining the nonlinear energy transfer rates in a wave spectrum. Yeah, Vaishnavi, please.
Good afternoon, sir. Am I audible?
You are audible. Can you please share your screen?
Yeah, sure, sir.
Please share your entire screen. Yeah, it's coming up. Yeah.
Is it visible?
Yes,
sir?
yes. Please go ahead.
Good afternoon to one and all present here. I'm Vaishnavi doing my research at VIT Chennai. My topic today is cubic spline polynomial as input energy spectrum for determining the nonlinear energy transfer rate in a wave spectrum. So this is the outline of my presentation, introduction, abstract of the work, computational technique being used, results and discussions, advantages of the method, and conclusion. So nonlinear wave-wave interactions plays an important role in the evolution of wind-generated waves. So in the discrete spectral wave model, the rate of change of an individual wave due to nonlinear wave-wave interaction is represented by a term which we call it as a source term, and it is known as a Boltzmann integral or kinetic equation in the energy balance equation, which is a 6-dimensional resonant integral involving delta functions. So the nonlinear interactions between the waves helps in redistribution of the energy among the wave components of the wave energy spectrum. So the abstract of the work is the nonlinear energy transfer between wind waves involves gravity wave spectrum plays a key role in the evolution of wind generated waves. So existing methods are there to solve this nonlinear source term, and the methods are exact methods and approximate methods. Exact method utilizes all the possible set of quadruplets to arrive at the result, and in turns it takes up the computational time will be more. So the pioneer researchers went on searching for the approximate methods, and the approximate methods does not require all the sets of possible quadruplets. So as compared to the exact method, the computation time was reduced, and also it was feasible to be implemented in the wave models. So the focus of my work is to present one of the method, which we call it as a Gauss legended quadrature method. And in this method, I tried fitting a splint fitted polynomial represented as an input spectrum in the place of the theoretical spectrum. So the results were validated and with that of the theoretical spectrum here. So the nonlinear results also presented to illustrate the reduction in the computation time of the method using cubic spline technique, employing a lesser number of points of the input spectrum without affecting the results. So imposing this technique in the Gauss legended quadrature method founded out a two-folded way, which is the input spectrum, either it is theoretical or measured or single peaked or multi-peaked, can be fitted using cubic spline, and the reduction in the computational time was observed. So this is the nonlinear source term, which we call it as a Boltzmann integral expression. It is a six-folded expression, and this is derived. The derivation of this process is given in these two literature, and the governing equation for deriving this process is our continuity equation, kinetic boundary condition for the bottom surface, kinetic boundary condition for the free surface, and dynamical boundary condition for the free surface. So these are the methods for computing the solution for the nonlinear source term. Some of these methods are exact methods, and some of these methods are approximate methods, and these are almost all of these methods has been inbuilt in the discrete spectral wave model. So the computational technique is here we have utilized GLQM method. The step involved in finding out or computing the nonlinear source term is as follows. The Boltzmann integral is expressed in this form, which is given in Web 1978, I cited, and this T of K1, K3 is nothing but the transfer integral. This transfer integral is evaluated by separately by in two cases. One of the cases when K1 grid is lesser than K3 grid, and another case is K1 grid is greater than K3 grid. So while integrating it while converting it into a polar coordinate and integrating it over a K2 and K4 grids, and we arrive at a line integral, and we express this line integral as a term as closed as over a closed locus with the arc length as S, as an integral parameter we call it as capital L, which is a length of the locus. So the step 3 involves the computational domain and discretization of this technique. So an input polar grid having a size nr comma n theta, the input polar grid is taken to be K1. So basically what we are doing here in this process is a polar grid for a two wave number vector has been chosen, which is K1 and K3 respectively, and K1 is our input spectral grid, K3 is our integration spectral grid. And the advantage of this technique is that we can vary the input as well as the integration grid by choosing the size of the input and integration grid. So input grid consists of the size is of nr comma n theta, where nr is our radial total number of points in the radial interval, and n theta is total number of angular points. In integration spectral grid, we have, which is K3. So this domain is a product of radial interval and angular interval. The radial interval is being divided into q subintervals, and the R is the number of points in each of the subintervals, and in the angular interval, we divide the angular interval into m subdivisions, and the small l denotes the number of points in each of the subintervals. And here this n log determines the total number of locus points. So the discretized form of this transfer integral using this n log Gauss-Legendre quadrature formula is given as this follows, where SI is the arc length. N log is the total number of locus points. So applying the L point Gauss-Legendre quadrature formula for the angular parameter theta 3, and also utilizing the composite Gauss-Legendre quadrature formula for the radial parameter K3, the discretized form of the transfer integral can be written in this fashion. So in terms of frequency, direction, polar grid, we have computed the nonlinear source term in this fashion. This nonlinear source term using GLQM can be evaluated for a given input wave energy spectrum by fixing the parameters L and log. As I told you, we can vary the input parameters Q, R, L, and log. So the one-dimensional nonlinear energy transfer rates SNL of f and SNL of theta are determined by integrating SNL of f comma theta with respect to theta and f respectively. So coming to the input spectrum, which is the theoretical spectrum, as described, we have the nonlinear source term is a two-dimensional spectrum, energy spectrum, which is considered as a product of two one-dimensional energy spectrum. And this 1D energy spectrum, frequency spectrum, which we have considered here, is a John-Swab spectrum, and it has been formulated as given below, where alpha is the Phillips constant, Fp is the peak frequency, and gamma is the peak enhancement factor, which vary for the John-Swab spectrum and PM spectrum. This is the directional cosine square directional spreading function. Coming to cubic spline fitted spectrum as the input spectrum. So spline technique is a piecewise continuous polynomial which can be utilized for a given set of points. So this is one of the popular smoothing method which can be utilized for evaluating the complex curves with provided given data points. So our main focus was we have been extracted the theoretical spectrum, input theoretical spectrum, the data points from the input theoretical spectrum. We have utilized the cubic spline technique to fit that input spectrum, and we named it as fitted input spectrum. And we observed that we observed this for two cases, for single peaked one-dimensional frequency spectrum and for double peaked one-dimensional frequency spectrum as an initial case. So what we observed that is for the input single peaked input spectrum, which has been depicted in this graph, we took 50 frequency points, which has been fitted using the cubic spline technique, and the parameters are given as follows. And we observed that as an initial case, the input theoretical spectrum has been perfectly matching up with the cubic spline fitted spectrum. And in the later case, what we did is we just incorporated this cubic spline technique, and we have extracted the points, and we utilized this cubic spline technique, and we have incorporated this in the GLQM method, and we have utilized come up with a graphical representation for the nonlinear source term with the input parameters given out to be this. We took 50 points as frequency points, and the angular points is 24, L is 10, and n log is 5, and the water depth taken here is a finite depth. And the main purpose of incorporating this cubic spline technique is that we can fit up the given data. The data may be a measured data or it may be a theoretical one. And the other main reason for utilizing this cubic spline technique in GLQM method is there is a reduction in the computation time was observed. So when we have tried out this technique for initially for the 50 points, the computed, and we have reduced the set of points, input points, to up to 30 points by using finite difference scheme, and we have observed that the graph has been perfectly matching up with that of the input theoretical spectrum, which has been observed in the 50 points. So
excuse me, Vaishnavi, you
yes,
have
sir.
1 minute 30 seconds left.
Yeah, sir. I'll just wind up. So
Okay.
this is the computational reduction which I have been observed in for the single peak. That is 62% of computational reduction. And this is the comparison of the 2D spectrum which I have observed for the 50 points and as well as for the 30 points. So in the left hand side it is observed for the 50 points, and the right hand side it is observed for the 30 points. So there is no change observed in the two-dimensional energy spectrum. So the same case, we have tried it out for the two-dimensional input spectrum, where it is the two John Swab spectrum together took as a two peak the input spectrum, and this figure depicts the 50 points frequency points along with the fitted spectrum with the parameters given as follows. And it has been incorporated in the GLQM method, and there is a reduction in the computation time, which is 68%, and without disturbing the graph, without disturbing the three-lobe structure of the nonlinear source term. And this is the comparison of the two-peaked spectrum for. The advantage of this GLQM method is the GLQM is convergent. With quadratures utilized, less number of wave resonating quadruplets is required. So we can optimize the input spectral data points based on the finite difference, so that the both accuracy and the reduction in the computation time can be achieved. So this technique can be tested for the input spectral data, input field spectral data. Currently, I'm doing, I did for the measured spectra, and I'm working on the validation process actually. So the conclusion is that the input spectrum is being fitted with the cubic spline technique. The nonlinear results using GLQM for both the input spectrum as well as for the fitted spectra was presented. So with the proper choice of the reduced points for the fitted spectrum, the computational time can be reduced of at least up to 60%. And with the validation of the fitting input theoretical spectrum using cubic spline done, the same procedure can be utilized for the field or measured spectra data. And these are my references. Thank you.
Dr. Gansilan, you are muted.
Sorry.
Yeah, no problem.
Yeah, thank you, Vaishnavi.
Thank you, sir.
Any question to Vaishnavi?
From chat, I can't see anything.
From the panel?
YouTube, from Saurav, anything?
Nothing from YouTube.
Can I ask a question?
Yeah, please go ahead.
Yeah, Vaishnavi, it's a nice presentation. Can you just tell us, like, did you conduct any experiments to check the sensitivity of the boundary conditions that is being prescribed for solving these equations?
Which one, sir, are you asking?
You have shown these Boltzmann equations, correct? And
yes, sir. Yes, sir.
have used
Yes,
some
sir.
dynamic boundary conditions to get it resolved. I think
yes,
you
sir.
have a set of boundary conditions. So
yes, sir. Yes, sir. That has been given in the literature, which I have cited over there, sir. There is a proper derivation utilizing these governing equations, and it is a process actually. Yeah.
No, my question is, did you check the sensitivity? Like there may be one set of boundary conditions being given. If let's say we'd like to make a different boundary conditions, will it be possible, or there may be improvement, there may not be? So I'm just wanted to, or curious to know, like what is going to happen if we are going to change the prescribed boundary conditions?
Okay. Actually, I was mainly focused on the solution for obtaining a betterment solution, or the computation. There is a reduction in the computational time observed for getting a solution for this Boltzmann integral. Actually, I'll just look into your point of view, sir, and I'll get back to you if I get it. So.
Okay, no problem. Thank you.
Yeah, thank you, sir.
Saurav has any question?
I was just curious about the reduced points you are taking, like suppose 30 or 32. So the computational time, is it a function of like the choice of your
Yes, sir. Yes, sir. Actually, the computational time can be reduced by making coarser resolutions of the input grids like K1 grid, where our frequency points and the angular parameters are there. So while reducing the number of frequency point, we arrive at the reduction in the computation time. Also, by varying the K3, the integration grid, which I have discussed right now, the K3 grid, where when you reduce the locus points, varying the locus point alone, we can check for the reduction in the computation time, and also varying the number of locus points, we can check the reduction in the computation time. So I did a validation, I did a convergence test for this by reducing the frequency points initially, and then by reducing the number of locus points and reducing the angular parameters also. Yes, sir. So by the reduction plays a key role here, because while we reduce the frequency points, this the choose the reduction points is in such a way that utilizing a finite difference scheme, by reducing this point, should not disturb the three-lobed structure of the graph also. So as I was showing you the graph, that graph was a three-lobed structure, which was for 50 points and 30 points. Further reduction in the 30 points, further reduction of the 30 points will cause deviation in the graph or disturbance in the graph, three-lobe structure of the graph. Yes, sir.
You will be eager to see how it applies in the actual data.
Yes, sir. Yes, sir. Like I just fitted the actual data. Actually, I'm just working on the validation part of it, sir.
Okay, good luck. Thank you.
Thank you, sir. Thank you.
Okay, Vaishnavi, see, what are the convergence tests you carried out with the finite difference scheme you have used?
Yes, sir. Sir, the convergence test for this GLQM technique is that by varying the number of locus points and by varying L, a small L, which I discussed for the integration grid K3. So we just fixed up these two parameters, and we fixed one and varied another one, like fixing L and varying the total number of locus points, and in the other case fixing the total number of locus points and varying small l, and in the other case we varied both the thing, and we checked up the computation time.
Okay, I have one more question. So I know
Yes,
you have focused more on the computational aspect, but since you have used the shallow and deep water definition in your theoretical spectrum, you know, you have used, for example, 5 meter and 100 meter. Okay.
Yeah, yes, sir.
The 100 meter you called deep water.
Yes,
So why did you call 100 meter deep water? So do you have any the criteria for that?
Yes, sir. When the relative density based on the finding it out as the wave height divided by the wave depth, or depth divided by the wavelength, when it exceeds to a certain point, it falls under for the shallow water.
That's what that's exactly I was looking for. You please explain in terms of wavelength versus the depth.
So
how do you?
Sir, for we have three cases, right? For deep water case, intermediate case, and shallow water case. And
any one case, deep water case, you can say the criteria. What criteria?
Yes, sir.
Okay.
Yeah.
Okay.
Yes, sir.
Thank you.
And actually, we are
thank you,
running
Vaishnavi.
late.
Yeah.
Okay,
thank
sir.
you.
Yeah. Thank you, sir. Thank you, sir.
For the
Thank you.
nice work and nice presentation. Yeah.
Thank you, sir.
Yeah, please,
Thank you so much.
Yeah.
Thank you, sir.
The next presentation by Srinivas Bolam. He will be talking on applications of AIML in fish biomass estimation system. Yeah. Srinivas, please go ahead. Please share your screen.
Srinivas, you are muted. Srinivas, you are muted.
You are not audible. We can't hear you.
Now is it audible?
Yeah, you are audible.
Very good afternoon to the chairman and all the members of the panel and dear participants.
I'm Srinivas Golan.
Can you please share your screen? And
yes. Is my screen visible now?
Yes.
I'm Srinivas Golam. I'm presenting this on behalf of my team Nitish Verma, Aarti Nair, Butkumruvel Dharni, and Dr. Tata Sudhakar. Before I go ahead with the presentation, I would just like to show you a video of what our product does. This is on the applications of AI ML in fish biomass estimation. So this is a real-time fish detection and biomass estimation system. Why we call it as intelligent is like it runs a ML algorithm which detects fishes in real time, and then the estimate of the fish length, and accordingly the biomass of it is actually calculated, and that data can be sent to in the form of an SMS to a mobile or to an FTP server. So this is the demo of that. So we can see that it detects the fishes with the, and on the top you can see the confidence level at which it considers as a fish. And now the approximate length of it and the biomass of each fish. So in this frame, this is the length of the fish and the biomass of it. This is how the validation is done in with the real fish actually, what is the length and the biomass. So now I'll go back to the presentation. By 2030, 62% of the fish food will be from aquaculture is a projection from the United Food and Agriculture Organization. Apart from that, like there's a lot of stress for protein requirement with the growth of population. Apart from that, fisheries is a promising field for our food resources in future. So what is the problem we are solving here and what was the requirement? NIOT has a lot of open sea cages which are deployed off coast of Andaman and in Chennai. And here we rate fishes, but there are 2 to 3 things which are manually required every day, like fish feed, which a person has to go and feed. Apart from that, estimating the size of the fish, so they have to actually catch it, kill it, and then weigh it to see whether it is ready for harvesting or not. But doing this every time when in the offshore, when in the high seas where we have monsoons and all going on, it's very difficult to do it every time. And we thought of why not replace it with a IoT device which could do the fish biomass estimation. Apart from that, we can also thought of getting other parameters like water quality, for example, the pH and the dissolved oxygen, which are also required for the fish rearing and other activities. So we have come up with a system architecture where we have a module with camera and 2 laser pointers. I'll tell you what actually they do. Apart from that, there is a edge computing platform which does real-time computing, which is powered by an AI ML algorithm. The other power sources and the data transmission modules which transmit the data directly to a cloud or to an FTP server, and also can be sent the data as an SMS. The output what we get is the length and the biomass and other water quality parameter, depending upon the sensors what we attach. On an overall, how we did it, like we collected the data, trained it on an RCNN module, then it is ported onto a Raspberry Pi board. Then it is deployed in the water along with Coral USB Accelerator, which is our edge computing platform. How we do the length and weight estimation. This is the formula using which we do the length estimation. Like when the length is actually calculated using a monocular camera, and from the distance of which the object is placed. And we use two laser pointers, where the laser pointers are shown on the fish. Probably I can show you the diagram. If you see here, these two dots are nothing but the laser pointers. Using that, we calculate the relative length of the fish, and using the depth, we calculate the overall length. Once we get the length, we can calculate the weight of the fish using an allometric equation very specific to that particular species. This equation can be derived separately for each species, whatever we are farming for. So this is the overall procedure what we are performing. One is object detection. Next is calculating the length of that, and from the length we are deducing the weight. This is the overall procedure we are doing in it. The novelty of the product is like non-intrusive, so there's no need to kill a fish to get the data of how whether it is good for harvest or not. The other major important advantage what we had is the fish feed optimization, like how much of food is required to feed it based upon its growth parameters. So this is called as FCR, feed conversion ratio, which helps in general fish farming to control or optimize the fish feed, which actually reflects in the costs. Apart from that, it has an edge computing, which forms the total calculation in real time. We had some processes which are available in the other countries, which does not real time. We have to, like, this is like post processing. We have to get the videos onto the shore and perform the processing. Overall, the footprint is very small. We named it as Drishti, and it supports both off-grid and grid modes of power. It is an IP69 rated enclosure, and we can deploy it in both marine and freshwater conditions. These are overall details of our product, and we have already applied for a patent through NRDC. These are few of the initial prototypes of our device, and this is our deployment in Andaman, where we got our results, the initial results, which were very near accurate with 95% accuracy. So where we are deploying it, like SIBA, ICAR, and CMFRI, so we already have some collaborators where we started testing it according to the species what they are growing. Accuracy and valuation, we have almost like 95% accurate on an overall. We have used Google Coral Edge TPU on our machine to perform the edge computing. So the other advantage of our overall procedure is like we are also able to do the testing or recognition in turbid waters, which is difficult in the other products available in the market. So we have Aquabyte and SKV Smart, and they are very bulky. Our product is around 1.5 kg, and all the others do post-processing, where ours is real-time processing. Ours is open source. Coming to the risks, like once we deploy it in marine environment, we have the problem of biofouling, which we are taking care of. Like we need like weekly maintenance near the camera position, where we just need to clean that camera glass. Apart from that, there are not much issues or the environmental impacts noticed. The other things are like we are also trying to integrate it with automatic fish feeders based upon the output from our product, such that the total fish farming can be like an integrated automated system with less manual intervention. Pros, apart from the affordability of cost and the reduced costs for the human intervention, we have some social and psychological benefits associated with that, such that people don't need to venture into high seas whenever you have cyclones and all. Apart from that, it's like making them sustainable to increase their profits and empowering them for a better community benefit.
Excuse me, Srinivas, can you just wind it up quickly?
Yeah. So this is one of our assumption. Like the only assumption what we had is like it can detect only when the fish is sideways. And the maximum and the minimum length is around 10 centimeters to 200 centimeters, where the average harvest length is around 55 to 70. On an overall, we are just collaborating with other ICR institutes and state governments promoting for fisheries to introduce this device. Device was also noticed by Google and was featured in the success stories by of GoTPU. So, any questions?
Thank you, Srinivas. Any question to Srinivas? Kunal, you want to ask some question?
As usual from chat, there is nothing.
Okay. If you have any question,
nothing from YouTube.
You have Kunal or
no?
Guru? Yes, Srinivas. I mean, you are using inbuilt AIML algorithm, right?
No, it is an in-house built AI algorithm, but it is taken from open source and it was developed, modified for our own requirements.
Can you tell us a little more in detail what is that AI and ML?
What we are using here is a CNN-based convolution neural network-based machine learning algorithm. Where
how does the CNN work?
CNN works by taking the image. It actually divides. It's like a divide conquer, where the total frame is actually divided into subdivision parts, and there are different layers in which the pooling happens, and each part is actually convoluted into a specific feature map. So from given frame, it creates a lot of features maps when we are doing the training. Now, when it is actually deployed for actual detection part, this feature map is actually used to identify the objects in the again the image. The same process happens. It actually divides the total image into sub parts using a mask.
How do you
Based
know
upon that, it is again actually.
How do you optimize the layers?
Layers, it all depends upon the threshold what we are looking for. Now what we have used is about the threshold range what we have used is about 0.75. It all depends upon what object we are actually detecting. For humans and other specific objects, we may need to lower it because the feature map may not be that particular. But for fishes, where what we are using it is very specific to a particular fish. So there's nothing like you have a lot of other things to be identified. If you can identify a fish, yes, that should be more than enough. But if you are using in a real-time environment where you have cars and all, the threshold level is what you need to vary to optimize it.
For different
our
species,
condition, it's,
like for suppose you get different species, you need to train them separately or?
Yes, initially in a cage you don't, I mean generally they don't rear more than one species. But this device can be deployed for any species. So once they tell us which species they are going to do it, we train it and the particular module is loaded onto it.
Thank you, Srinivas. Okay. Thank you.
Thank you very much.
Thank you.
Yeah. Yeah. So can you just tell us about the training data and the original validation data? Like, do you have different data sets for this purpose?
Yes. Obviously, we have to create two different data sets for validation and the training. So we take one particular day, sort of 10 hours of video, create frames from it, and then divide that data set into like 80 to 20% training and 20% for validation. That's how the training goes on.
And how this training data is varying from species to species? Any dependency?
Only the feature set like the fish, this thing modifies. Otherwise, there is no much variance.
Okay, fine.
So the training is very specific to a species. We have to do it again. Once we have the training done, you can deploy it any number of machines. So that should be an issue.
Okay.
Thank you. Thank you, Srinivas. Thank you, Srinivas, for the nice work and nice presentation. We move on to the next presentation. Next presentation is by Subrata Haldar. He will be talking on assessment of CMIP6 models, skill for tropical Indian Ocean sea surface temperature variability. Subrata, please.
Yes, am I audible?
Yes, please go ahead.
Yeah. Good afternoon, everyone. I am Subrata Haldar from Indian Institute of Tropical Meteorology. Here I am PhD scholar. and today I am going to present my research work on assessment of CMIP-6 models skill for tropical Indian Ocean sea surface temperature variability. So here goes the introduction. So Casero et al. 2017 reported that ocean plays a central role in decadal climate variability because of their thermal and dynamical inertia. Actually, most of the prominent decadal variability pattern like PDO, IPO, or Atlantic multidecadal oscillation, they are relatively well studied. But in the Indian Ocean, recently, the Lee and McFadden, Han et al. And many other studies, they found that decadal variability is there in Indian Ocean sea surface temperature. And the UF of low-pass filter SST anomaly shows a basin-wide pattern, and that explains 54% of total variability. And Han et al. 2014, they reported this decadal variation as a decadal Indian Ocean basin mode. And here is the corresponding PC. And also Bihute and Subroto Haldar et al. 2020, they also show that UF1 of bandpass filter, 9 to 30 year bandpass filter, UF is also showing a decadal variability pattern over here. So, but this physical process behind this is not well studied in the observation as well as in the CMIP-6 models. So this motivated us to study the skill of this SST variability decadal as well as annual in the CMIP-6 model. So here are the data and methodology. We have used ERSST version 5, atmospheric deliverances ERA 20C, and historical run output from 27 CMIP-6 model. Here are the list we have used. And the techniques are used: spectrum analysis to know the dominant frequency of the signal, low-pass filtering to extract the low-frequency signal, and EOF analysis to find the dominant mode of spatial pattern of the variability. And Taylor diagram to show the skill. So here are the data analysis steps we followed. So results we are getting that here it is the spectrum analysis of the detrended annual TIO SST from ERSST version 5 and all the 27 CMIP-6 models. So here we can see that the observation is showing 2 peaks, power peak over 4 year, and here approximately 16 year, and here it is about 8 year. So from observation, we can see that there is a periodicity of decadal periodicity of 12 to 30 years, as well as in the internal around 3 to 6 years. And these signals satisfied this, and this peak satisfied 90% confidence level. And from the analysis from models, we can see that BCC, CSM2, MR, and these models are producing, capturing the decadal variability signal, but the power is getting shifted towards the higher periodicity, and also that variability is underestimated in all the models. Here, these figures are you have leading mode of TIO annual as well as filtered SST anomaly. So here we can see that in the observation in the annual it is explaining 35%, and all the models are capturing the decadal annual spatial mode. But there is a little disparity in this model in which they are showing a little dipole type of pattern, as well as in the decadal also all the models are capturing the UF spatial pattern, but there is also disparity in IPSL CM6ALR as well as this GSE21G. It is showing little dipole type of pattern. After that, we went for the correlation matrix with these 27 models output and the observation. that UF special pattern we have correlated with each other, and we found the correlation matrix, and from there we can see that in internal UF pattern correlation is having more than 0.5. But only for this CNRM ESM21 and INM CM5, they have very less correlation with the observation. That is also about minus 0.1. And for decadal, we can see that correlations in most of the models and observation, the correlation is more than 0.5. But VCC ESM and correlates with ERSST V4 and MIROC 6 and MPI ESM 1 to HR, they correlates very less, that is minus 0.1. And now here we went for the skill of the models to capturing the decadal in Indian Ocean basin mode as well as annual Indian Ocean basin mode. So here we presented the Taylor diagram. The total root mean square error can be expressed with this formula, where E bar square can be explained as the standard deviation of the field means model, and the standard deviation of the reference means here observation, and also with their correlation, which is connected with this formula. And also the skill score is calculated following the Taylor 2001. So here in the Taylor diagram, this axis is showing standard deviation, this axis is showing the correlation between observation and the model, and this axis is showing the RMSE. From here, we can see that F goals F3L having very good standard deviation, and also for the case 10G. And these models are showing very good correlation. And so we went for the skill score analysis, and we found that for interannual, it is case 10G, F goals F3L, and ERSST EC Earth Veg LR are showing very good correlation. And here are the for decadal variability, it is F goals F3L and CAN ESM 5 CAN-OE and case 10G and others model. And then we went for process study, and here we are showing the skill score for annual as well as decadal, and that is for net heat flux, latent heat flux, and for net radiation. And here it is for U wind, V wind, and wind speed. And the models they are according to this score. We have we have the models according to the SST score. So here from here we can see that model have better radiative flux, but the score for latent heat flux is very less, which actually is reducing the score for net heat flux. And also for this the U wind and V wind and wind speed, all they are showing a good score for the models which are having better skill score for SST. And similarly for decadal variability also, we can see that actually models are underestimating the skill in the latent heat flux, which is actually further reducing the skill for net heat flux. And we conclude that model have improper wind SST evaporation feedback. And also here F goals F3L, we can see that the skill score for zonal wind and latent heat flux is comparatively highest, and which actually leads to better decadal variability of TIU-SST. And for process study, here we actually regress the PC1 of sea surface temperature anomaly over the SST and the wind vectors and mean sea level pressure contour. And And in this figure, it is the regression of PC1 of sea surface temperature anomaly over the latent heat flux as well as net heat flux, which is contour. So from here in observation, we see that the Pacific, Eastern and Central Pacific Ocean are in phase with this decadal modulation of the Indian Ocean SST, and which in turn actually is in positive phase with the Indian Ocean SST, and the anomalous Walker circulation is playing the role to connect the Pacific variability with Indian Ocean variability. And we also seen that variation in radiation and latent heat flux are primarily responsible for decadal basin-wide variability of TIUSST. And the model in which the latent heat flux and zonal wind are better capturing are producing better skill for TIUSST variability compared to other models, and which model are not capturing properly the latent heat and zonal momentum flux, that leads to improper wind evaporation SST feedback and wind circulation SST feedback, which in turn restrict the model skill.
Subrata, you have 1 minute more to conclude.
Okay, sir, thank you. And here, here are the summary and conclusion that we have seen that most of the CMIP6 model display internal decadal variability dominant in TIO SST, close to what is found in the observation of more than 160 years. It is important to note that though the model captures the variability, the strength in general is underestimated. And the skill score analysis found that CASE 10G have highest skill, followed by F-goals F3L, ECR3 VSLR for internal variability, and F-goals F3L, CAN ESM5, CAN OE, and CAN CASE 10G respectively, having the better skill for decadal variability. And also the highest discrepancies in latent heat and zonal momentum flux may lead to improper wind evaporation SST and wind circulation SST feedback, which is restricting the TIUSST variability skill. And here is the publication from this work, and here are the reference. And I just want to acknowledge
thank you,
the
thank you,
director IIT
Subrata.
MOES.
Thank you, Subrata.
Yeah, thank you, sir.
Any question to Subrata?
Yeah, so Subrata, it's a nice work.
Thank you, sir.
Did you include our IITM's ESM for this comparison?
Yeah, actually, sir, here in this analysis, we got this model having number of members more than 3, which are having more than 3 members. We are including those models, but for IITM ESM, I didn't find more than 1 member, and as well as at the same time, many variables like U, V, and other heat fluxes variable, they were not available during my study. And also that's in the 3 months ago, I also checked, but those are not available at this moment. So when it will be available, I will use those.
Okay, okay, fine. Thank you.
Okay, thank you, Subrata. Thank you, Subrata.
Sir, may I ask?
Yeah, please. Yeah, please.
Subrata, just curious, is there any particular reason you don't look at the advection? You looked at the heat fluxes only.
Sir?
Is there any particular reason you didn't look at the advection? Like for the skill score of the models, you have looked at latent heat flux and the net radiation, but not the advection. Is there any reason for that?
No, sir. That is actually remaining, sir. I will study those advection. It is I have studied only for atmospheric pathway, but oceanic pathway I have to study, sir. That is remaining.
Since your domain include ITF also, so I was just a bit curious. And one more thing, if you look at the first figure, UF, the base and the PC1 of that, whether like is it the internal Indian Ocean thing, or that have you tried correlation of that PC1 with any other maybe Pacific decadal variation or something, any other dominant modes?
No, sir, not yet, sir.
I was just curious whether that Indian Ocean, the PC1, which you are showing, whether it is influenced by some other basin modes also.
Yeah, that's a good question.
I'll check.
So brother, say, what is your hypothesis? Like, because you have a basin scale warming in the decadal time scale. So what is the forcing? So from where it is coming?
Sir, actually, it is getting forced from Pacific. Pacific, that Eastern and Central Pacific is in phase with the Indian Ocean basin-wide mode. So the mechanism is like we have the if we have the warming over the Central and Eastern Pacific, there will be anomalous water circulation. It will be it will converge toward the in the surface level. It is toward the Eastern Pacific, and it is downward in the Indian over the Indian Ocean. So actually it is suppressing the convection, and for that the radiation means downward radiation is getting increased, and the Indian Ocean is getting warm. So in this way, so from that observation we are getting, but which models are not producing this connection, they have very less skill in our study we see.
But the tropical Pacific variability is mostly in the interannual nature, right? So you're talking about interannual or a decadal perspective?
Yes, sir. In interannual also, and in decadal also, IPOC means interdecadal Pacific oscillation, and also PDO, both are actually modulating this in decadal time scale.
Okay, thank you, sir, brother.
Okay, sir. Thank you.
Yeah. So we move on to the. Can you please exit? Stop sharing. Yeah. Next presentation is by Mayur Gajanan. We'll be talking on using machine learning to characterize ocean basins. Yeah, Mayur, please.
No, I don't think he is available.
Okay, we move to the next presentation. Hitesh Gupta will be talking on sea surface temperature projection for the Bay of Bengal under RCP 8.5 using 1D PWP model. Hitesh, please.
Yes, sir. So are you able to see my screen?
Yeah, please go ahead.
Yes. So good afternoon, everyone. I am Hitesh Gupta, a PhD research scholar at IIT Bhubaneswar. Firstly, I would like to thank my co-author, Dr. Saraswat, for helping me out in carrying out this project, that is sea surface temperature projection for the Bay of Bengal under RCP 8.5 using 1D PWP model. And I am thankful to OSI for providing me this opportunity to showcase this work. So firstly, I will discuss in brief about the domain of the study, that is the north part of the Indian Ocean, that is Bay of Bengal. The North Indian Ocean is unique among the world's ocean because it is bounded on the north by the Indian landmass, and its dynamics are primarily governed by seasonal reversing monsoon wind system, that is southwest and northeast monsoon winds. Now the Bay of Bengal is located on the northern side of the Indian Ocean and a special body of water, that is a semi-enclosed basin that receives a significant amount of fresh water from rivers as well as rainfall during the monsoon season. And the turbulent mixing in the upper layers of the Bay of Bengal is affected by shallow layer of fresh water overlying the hypersaline water of the bay due to freshwater influx. And now due to the resulting steep halocline, a wind-driven mixing is inhibited due to the stratification, and this shallow brackish layer also affects the optical property of water. So by the optical property, here we signify the penetration depth of the solar insolation. Now I just told that the brackish layer affects the optical property. Therefore, this slide gives us some information about solar insolation and how it penetrates and what happens due to the penetration in the ocean. So it is very well known that the solar insolation is composed of a spectrum like visible, IR, microwave, etc. that reaches the Earth's surface. So from the first and the second figure, we can see that the blue light or the shortwave component of the solar radiation penetrates deep into the ocean because of its high energy, which is defined by E is equal to S by lambda, whereas comparatively larger wavelength like red color penetrates much less, owing to its low energy. Hence, the energy distribution in the ocean depends on these depths to which different component of light penetrates. Hence, penetration depth is a function of wavelength of the light fields. Now, we know sunlight is the primary source of energy for the photosynthesis. Now, depending on the depth of the penetration of radiation, different zones of the oceans are defined, like the photic and the aphotic zones. Hence, it is very much important to be able to simulate these penetration depth and the resulting thermal structure. With the exception of the shortwave insolation, the air heat exchange occurs at the sea surface, which is vertically redistributed due to mixing and advection. And it is very much logical to now think that if penetration depth is less, the heating will get confined in upper layers, and this will lead to heating of the upper layers and vice versa. With this note that insulation affects the whole dynamics of ocean, we started carrying out different experiments using 1D PWP model. So this slide defines the objective of this study. So first is the estimation of absorption length for penetration depth for the e-folding depths for long wave, that is IR component, and short wave UV visible or UV blue component of the solar insolation using simulation of upper layer temperature using 1D PWP model. And the second, we studied the impact of increased radiative forcing by 8.5 watt per meter square using representative concentration pathway, that is RCP 8.5, on the ocean or the Bay of Bengal temperature. So before going into the study, it is also important to know some basic aspects of the model and how it simulates the thermal structure. So PWP is a 1D or one-dimensional vertical mixing model, which is based on dynamic instability and uses bulk and the gradient Richardson numbers, along with some diffusion equations to simulate the mixture. And it was initially formulated to analyze the diurnal thermal cycling in the upper ocean, which relies on daytime solar heating, nighttime cooling, and wind mixing of the upper ocean. The wind forcing of the ocean is primarily in the form of wind stress, which measures the rate of momentum transfer and affects the velocity of current. So to understand how a thermal structure is generated, we must understand the radiative forcing and how ocean is forced by solar insolation. So this is the heat budget equation, which is used in the model to estimate the evolution of temperature. This equation is most important for the study of absorption and the thermal structural simulation. Here F in the equation is the air sea heat flux, which is the sum of insolation and the heat losses, where the heat loss comprises of sensible heat, latent heat, and the long wave radiation from the ocean to the atmosphere. And in model, the insolation is parameterized using the double exponential decay formula given by Paulson and Simpson. And here the I1 is the long wave IR component of solar radiation. I0 is the solar radiation at surface. I2 is the solar radiation short wave part of solar radiation, that is UV blue component, and beta 1 and beta 2 are the long wave and short wave e-folding depths or the absorption. E-folding depth is the depth to which an exponentially varying quantity changes by a factor of E, that is its magnitude either increase or decrease by a factor of E. Hence we call it penetration or the absorption, penetration depth or the absorption depth. So coming to the forcing and the initial condition data, there are some, these are the forcing and the initial condition data that is required to initialize and run the model. Forcing include the short wave, long wave, sensible heat, latent heat, wind stress, evaporation, and precipitation. And the initial condition that is required to initialize the model is salinate temperature and density profiles. Since PW model is a 1D model and therefore it requires observation at a single point along with the variation in depth, hence the data from the Raman buoy is used, and a series of Raman buoys are installed along the 90° east at different latitudes in Bay of Bengal. Raman buoy were introduced to study the role of ocean on monsoon dynamics. It also provides all the flux and the ocean parameter required to run the model. Hence, Raman buoy acts as a perfect in situ observational point for the PWP model. So initially, the study for the determination of absorption length and the impact of RCP 8.5 was carried out for the RM15, that is Raman buoy at 15° knot, but it was not confined to RM15. The determination of absorption was carried out for RM12, that is 12° knot, and RM8, that is Raman buoy at the 8° knot, which is shown in the figure. It was an attempt to generate this absorption length for a different location in the Bay of Bengal, and it shows absorption length not only varies with time, but also varies with space. So now, in order to perfectly simulate RCP 8.5 in one-dimensional PW model, we must first be able to simulate ocean thermal structure properly to reduce the bias between simulated temperature and observation, and to reduce the bias sensitivity study of different absorption lengths are carried out. Here, the model considered that insolation consists of two wavelengths in general, that is the UV blue component and IR red component. And when this sensitivity study is carried out at the location of 15 degree north and 90 degrees, that is RM15, it was found that e-folding depth for UV blue component is around 40 meter and IR red component is around 5 meter. As shown in the figure, as temperature in the model shown by the black curve is close to the observation. Observation is the black curve and blue is the beta equals to 40 meter, that is the UV blue component penetration depth is 40 meter. Therefore, the penetration depth of 40 meter and 5 meter is used to carry out RCP 8.5, as these values gives more realistic ocean thermal structure. And these value of penetration depth are determined statistically by comparing RMSEs and correlation coefficients between different penetration depths. So before carrying out RCP or any other further analysis, we determined model performance on the basis of similarity temperature and the observations from the Raman wheel. Now to check the model response, we carried out normalized cross correlations. And on carrying out normalized cross correlation between net radiation versus observed temperature, it can be observed that there exists a lag of around 36 days. It means in reality the temperature is responding to the net radiation after around 36 days, or it is the basic relation between the net radiation and observation. Now the most interesting thing to note is that the normalized cross correlation between the net radiation and model temperature for beta to 40 and 20 meters are also showing a lag of 36 days, which means that the model temperature is responding to the net radiation as same and as fast as that of the actual temperature. Now to verify this, we carried out normalized cross correlation between the actual and the model temperature in the last figure, which clearly indicates that there exists no lag between the model temperature and the observed temperature. So this outcome is assumed to be marvelous when seeing the simplicity of the model. So now we should come back to our original topic of RCP 8.5. So starting with the basics, so that we come to a common point of understanding, like what is representative concentration pathway. So we need to first define the radiative forcing. So it is defined as the change in the net downward minus upward radiative flux expressed in watt per meter square at the top of the layer as a result of changes in greenhouse gas concentration. Here we are talking about long-term concentration and not the instantaneous emissions. So the Intergovernmental Panel of Climate Change, that is IPCC, has introduced a representative concentration pathway, that is RCP. For greenhouse gas concentration, the RCPs are compatible with wide range of potential anthropogenic gas concentration. And to predict how our environment will change in the future, we must be able to predict how we will. For example, we will continue to consume fossil fuels at an ever-increasing pace, or will we turn to our renewable energy sources. The RCPs attempt to predict future patterns, and they forecast how the concentration of greenhouse gas in the atmosphere will change as a result of human activities in future. There are 4 RCPs which vary in potential concentration from very high, that is RCP 8.5, to very low, RCP 2.6. The numerical value of RCPs refer to the future concentration in the year 2100. So the focus of this study is the RCP 8.5 using 1D PWPL. So RCP 8.5 is a high concentration mechanism of greenhouse gases in which radiative forcing exceeds by 8.5 watt per meter square by 2100. Now this figure shows the Earth energy balance system, as this balance is affected, which may be due to the introduction of greenhouse. Yes, sir.
Because you have 1 minute more.
Yes, sir, yes. Radiative forcing will be induced, and positive radiation will lead to heating of the Earth system. So, these are the 2 methods that have been used to integrate RCP 8.5 in the PW model, which is the diagonal thermal cycling model, to study the impact of increased CO2 in the ocean and atmosphere. First is increase in insolation, incoming solar radiation by 8.5 watt per meter, and second is the decrease in outgoing long-wave black body radiation by 8.5 watt per meter square. Figure 5 shows the 4 characteristics of the black is observation, magenta is model temperature without RCP 8.5 for extinction length of 40 meter, and the red and blue curve are for RCP 8.5 with method 1 and 2 respectively for extinction length. Since RCP 8.5 are model temperature, it would be appropriate to be referenced with the model temperature with RCP without RCP. So it was found that using case 1, increasing mean temperature is on 0.64 degrees Celsius and increasing maximum temperature is 1.14 degrees Celsius, whereas using method 2, increasing mean and maximum temperature is 0.77 and 1.42 degrees Celsius respectively. Therefore, it can be said that by the year 2100, the maximum temperature of the Bay of Bengal may be increased by around 1.5 degrees Celsius. And these are the conclusions which I have already discussed in my previous slides. And these are the references. Thank you.
Yeah, Dr. Selan, you are muted.
Thank you, Hitesh. Any question to Hitesh?
From chat box, there is nothing.
Nothing from YouTube as well.
Okay, so I have a question, Hitesh.
Yes, sir.
The RCP 8.5 is an extreme case, right?
Yes, sir.
That may not be realistic. Have
Yes,
you tried with RCP 2.6 or 4.5 or any other scenario?
No, sir. Right now, I am thinking of doing it in the future because this was my master's project. So
okay. Another question. Yeah, another question is: see, you are using a one-dimensional model.
Yes, sir.
And at a Ramabui location.
Yes, sir.
How do you get forcing from the global model, because that's a very coarse resolution model? How do you?
Sir, I have taken the forcings from the Ramabui itself. Ramabui provides the forcings, all the forcings.
Ramabui gives. We don't give you projections, right? You are projecting.
No, sir. No, sir. No, sir. That for the RCP 8.5 you are asking for.
Yeah.
Sir, I have not changed much of the forcings because in RCP 8.5 we say that the radiative forcing will change by 8.5 watt per meter square. So I simply used the old insolation and the outgoing long wave radiation and change the value by 8.5.
See, but 8.5, this 8.5 value is not at one location, because you are looking at one location, so you cannot use that 8.5 at one location. So that is an average value. So that's a global average value.
Yes, sir. Yes.
Okay. Thank you, Hitesh. All the best.
Thank you, sir.
Yeah.
Thank you, sir.
So this is the final presentation. So I thank all the speakers. Yeah. So all the speakers can now leave this live stream. So you can join the YouTube now. So I request Dr. Kunal and Dr. Saurav to stay.
Yeah.
Others can leave. Please log out from here.
So the host from NCPUR, can you just stop the live streaming?
Sure, sir. Sure.
Yeah. Thank you.